Important day today. All 5 days will be technical. Okay, just give a second. I'm refreshing this. I think yes, the screen is showing stuck. Let me quickly refresh this. It got it back. Okay, team. So we are live. Let's get started. Important discussion. Yes, let's go. Guys, you can hear me loud and clear. Give a quick thumbs up. Okay, the screen is visible. Everything is okay. Yes. Okay. Fine, guys. Let's get started. Today we are going to discuss some microservice related principles from technical perspective, which you can add in your resume, and it is going to be practical demonstration of few concepts. Okay. So chalo, let's get started. So we are going to focus on two major concepts today. Okay. And let's say if we can finish all the two as part of today's connect. However, some we might have to do it otherwise tomorrow. Let's see. The topics are big in itself. Let's see. Firstly, so as part of week 7, we are going to focus on completing, yes, few microservice related, few technical things will be there. Next, we need to build one Redis cache use case. This is another thing which we have to complete. Next, we will be doing something in unit testing. Next, something working with logging. Okay. So these are the primary aim of this. And let's see. So this is the core target. So microservice related principles, this we have to definitely finish in these 5 days of time. So Redis cache use case, working with unit testing, working with logging, and some microservice related principles. Okay. And starting today, we will be doing this. And then every single day is an important topic. You would need to include these things in your resume. So definitely practice these things as well. Okay. Make it hands-on. It will be very useful. Chalo, starting with microservice related tech principles. We are going to discuss first one today, which is circuit breaker. Okay. And after that, we are going to even touch another topic, which will be working with service registry. Okay, working with service registry, something like Eureka server and Eureka client. So this is one aspect of how coding can be done in microservice when one service is talking to another. So last week we have used a REST client way of directly calling them based upon endpoint. Another way could be using this service registry also we can achieve it. So we will spend some time via this approach, how exactly our processing service can talk to provider service. Processing service talking to provider service. So instead of directly making API call via the domain or endpoint directly, we can use this combination. In some projects, this approach is also utilized. And the second concept is circuit breaker. Okay. So these two things we will start with circuit breaker and then move to the next one. Fine. Okay, let's understand the problem statement first. I'm opening Paintbrush. Very interesting concepts are there, so please put your entire attention here. Okay, let's start. Okay, so first of all, now what is happening in microservices? Yeah, there is a need where one system, one service talks to another service, right? So we have this processing service, and this service is talking to another service, PayPal provider. Okay. So whatever approach you choose, whether you use direct endpoint call, what we did last week, or you use service registry and Eureka, basically for both, okay, internally an HTTP call is going to be triggered, right? Because REST APIs are exposed, REST works based upon HTTP protocol. So whether whatever approach you follow, endpoint or service registry based approach, in the end, HTTP call is going to happen. It is REST over HTTP model, okay? And we know that whenever we have done so much of error handling, so we already know these facts. Whenever you call external guy, multiple possibility exist in a response, right? One possibility is this guy itself responds with a success, or this guy gives valid failure, nothing but some error object will be given. Third is simple timeout, no response, service unavailable. These kind of issues can come. Okay. So one thing you need to understand about microservice, that lot of consumers can also access the destination services. Currently, our project is in a situation that processing service itself is calling it. Processing is only calling a PayPal provider. Okay. But the core design of microservice says what? If another service also wants to consume some information from PayPal provider, so they can also directly call it. So that is open. Matlab, microservice allows that kind of communication. Whenever somebody wants to use, they will use. Okay. Now, what happens is, whenever there is a request, okay, hello, I hello guys. Okay, I think there was some network drop. Is it back again, guys? Now can you see the screen, everything? Okay, no problem. I'll repeat it again. There was this Wi-Fi got restarted, so I was able to notice that. So I did not discuss any topic. Okay, okay, chalo, no problem. Thanks for confirming. Let's switch back. So okay, what problem we are discussing? So basically in microservices. So thanks for confirmations, everyone. Let's continue back on our topic. Here we are. Okay. So basically, microservices means there are a lot of services which do some specific function, which run some functionality. Okay. Now, in that, there might be a requirement that one service wants to talk to another service. So whenever they are talking, in return, multiple possibilities can be there. Success response can come, error response can come, or no response can come. Timeout, service unavailable, gateway problem, or just network failure, that response itself does not reach. So these three possibilities always exist. And now what we are saying is, whenever in a microservice, currently we have only processing service calling PayPal provider. But microservice allows that if any other service also wants to take benefit of PayPal provider, they can also directly call this and get the response. Okay. So first conclusions, we have to understand this itself, that any number of microservices, okay, can call destination microservice. Okay, this is one. Next, when any call happens, it has three possibilities: can give success response, or valid failure response, or simply timeout related problems. Okay, and now third thing you need to understand is, sometimes it is going to happen that, let's say, too many requests are coming to this service, from this guy also, this guy also, this guy also. Eventually every service runs based upon some memory, right? It needs some RAM, it needs some CPU processing power, it will be utilizing some hard disk capacity, and yes, they are going to be load balanced and multiple instances and all will be there. But there will be possibility, even after those load balancing and all, there will be possibility that some of the services can slow down. Let's say when concurrency is happening, many requests are coming at the same time. By default, the HTTP threads are around 10. So if all of a sudden many number of requests are coming, so they will first try to allocate to this microservice, and maybe not able to process all. So some requests might be in a waiting state. Next, there could be possibility developers have written some code, okay, go to the database and do certain activity or call external services. There could be some threads waiting for DB operations to complete, waiting for external call and results are not coming properly. Sometimes bad logic might be implemented here. Means for processing one request, unnecessary sometimes 3 to 5 seconds of processing time is happening because of some logical problem. So that means there could be several issues because of which this service might perform slow. And if this service is performing slow and parallelly many users are requesting to process, automatically you would realize a lot of timeouts will happen. Every request will take a lot of time for processing, and a lot of timeouts will happen, and that means the service is not in a stable state to serve our entire traffic. So try to understand the major problem that is happening here. Already this service is slow, and concurrently a lot of people are still making requests to that service, and this guy cannot really process it fast, and it starts failing all the rest of the request also. Okay, so this is what is our main problem statement, why circuit breaker is actually required. So our third possibility which exists is, okay, our third possibility which exists is when, okay, sometimes the destination service might slow down, okay, waiting on DB call to complete, or external API call, or some logic is taking more time to process. Okay, so the core service, the destination service, okay, is slowing down, and in parallel the consumer services are making more concurrent API calls. Just assume this, these are all consumer services, and this we are calling destination service or producer services. So this guy is not behaving well, and still these people are calling. What happens is, furthermore load comes, and this service is not going to function properly then, right? It is already not working, and more requests are coming. So automatically this service will go under so much of load, and recovery is not going to be possible, right? Because what happens, just think why recovery is not possible. Let's think about this concept. When these requests are coming at the server level, if they are not able to process it quickly, still some maintenance might be there, like tracking this request, keeping the request available, that when existing requests are completed, then this request should be taken and processed. So it is quite possible for tracking this request, allocating all that, there also time is going to happen. For that also resources are required, and earlier the system is already not doing good. and in that, so much of load is adding much more complexity here. So eventually the number of requests to process will grow so much more that system is not able to really recover, because it is already behaving slowly, and a point will come, this service will completely be shut down itself, and we have to start a new service to process the new load. This happened for many production scenarios as well. Okay, so what is happening? Main problems are, if the service performs slowly and still the users are trying to call that service, a point comes, this service cannot recover back because this new load is killing it. It's not able to restore itself again. And because of that, eventually this services has to be closed, terminated, and new instances should be launched with proper traffic handling and everything. Okay? So this is the main problem statement that we are dealing. When a service is not performing good and these other guys are calling it, it gets into a state, they all will never get the response, plus this service never recovers also. That's the main problem statement. Okay? So let's write it down. So when destination service is performing, okay, or responding in slow manner and huge concurrency happens, then we are anyways not able to respond to the incoming request. Okay, so that is anyways a problem. Okay, and secondly, the destination service is not able to recover from the problem as well. Okay, and automatically, eventually, this leads to complete shutdown of destination service. Okay, this happens at times, so please be aware. So now the problem is, this is a major concern. Okay, actually this can be clearly applied to a human situation also. Okay, you take a human being and start putting pressure on that person about something, right? Okay, do this, do that, do this, do that, do this, do that. When so much of parallel concurrent request happens, and if that guy is already not in a mental state to finish all those things productively, okay, and let's say already that person is not in a good state of health or whatever, and more workload is being given to that person, end result is a complete collapse, right? Severe health problems can happen in such situations. Same thing is happening with microservice also. So what could be a good scenario here? When the person is down and in problems, rather than adding more load to that person, stop that kind of load and give time to the person to recover, the health to get better. Once it get better, anyways, when a new request comes, that person will be able to solve. Try to relate with a human situation. Somebody is having health problem, some signs are there, not able to do things faster, and you are giving more load. He's anyways not going to finish the load, plus there is a mental pressure and tension which makes it more worry, and end result may definite bigger problems will be there. Same thing is happening with microservice also. Service is unhealthy right now. It wants some time so that it can recover back properly, but we are adding more load to it. Service becomes not in a good state to recover. So how do we solve this problem? Okay, so try to relate with this. It is same, directly proportional example. So how do we solve this problem is using circuit breaker. Okay, circuit breaker. देखो, the name it suggests, right? Circuit breaker. थोड़ा electric circuit के साथ try to relate it. We know wires, right? So when there is a, let's say, light, and there is a wire, and then there is this plug which goes into that electric slot, and then you put on, and then light comes. That means it's a proper circuit, closed circuit. If you cut the circuit, let's say you take a scissor and just cut the wire in between, so what happens? Whenever you turn on the switch, the current does not pass to the light, and the light does not glow, That is nothing but circuit breaking. You just have to relate with the electric circuit concept itself. When this service is trying to call to this service and you realize that service is not performing good, in that case, you simply break the circuit. Means you don't call them, as simple as that. You break the circuit. The way we are cutting with a scissor that wire in between. So what happens? Both are now two different parts. Okay. So you simply break the circuit. Once the circuit breaks, that means new calls are not reaching the destination. And when new calls are not reaching, just imagine all of these services will be applying the circuit breaker mechanism. As soon as they realize that, hey, this service is under load and not performing properly, circuit breaker mechanism will activate at all of these services, where they will say, okay, so let's not call that service anymore because we already know that it is not able to perform. So what you're doing is you're saving even network traffic. Lot of IO and network bandwidth was consumed. Dekho, when the service is not performing good and you make the API call, you utilize network resources. Even though if it is going to time out, but some IO activity happens, you need that internet capability to make that call. So all that is also adding to network congestion. So what is happening is, so this service is not performing, you are adding more to the network chaos. So as a conclusion of this, circuit breaker mechanism comes in picture. Circuit breaker simply says, as soon as you realize that destination service is unhealthy or not doing good, what you do is you stop calling that service. You assume that it is going to fail for some more time also. Means you have to assume failure. So because anyways you're not going to get response, so why to call and then know that you're not going to respond? Circuit breaker says you assume failure already and stop calling that service. Same logic is told to all these people also. This will, and then you're not calling that service anymore. This will give time to this service to recover. Means whatever right now it might be doing some DB stuck operations or API call, since more load is not coming, all the threads and the computation power and memory will be utilized to finish the current bothering work. And then slowly service is going to get back in shape. And once it gets back in shape, you will now then remove this and then start actually calling it again as well. Okay, then you will actually start calling it again as well. That simple mechanism is circuit breaker mechanism. Okay, guys, focus. We'll re-summarize the circuit breaker mechanism once more. There is a destination service, there is a source service, or producer service, consumer service, whatever terminology people might use for explaining this. Okay, so there is this destination which we want to reach. There is the source service. When we are calling them, if destination is not performing good, circuit breaker says, hey, don't call them, because anyways you are not going to get response, plus there is burden on that service and that service might never recover. So circuit breaker says, stop calling that service, rather assume it is already failed and do your business logic processing assuming a failure. Okay, likewise all these services will do. So when there is no more traffic going to this service, all the thread, CPU, RAM, everything will solve the existing problem why this service was not able to perform good. And once the problem is solved, the service gets good, able to do real-time processing, and then you remove this breakage and then more requests can flow further in the system. So that is nothing but working with circuit breaker mechanism. Okay, so let's write down conclusion here. Okay, what is circuit breaker mechanism? If destination service is not performing good, okay, then source is expected, okay, to stop calling destination service. Rather, assume a failure, already assume a failure. Because anyways, when you call, then also you're going to get failure. So why to call and get failure? Right now, in the code itself, you assume ke, ye to gaya. This is going to fail. So rather, assume a failure already. Assume a failure already and process at your end. Already error handling mechanism we have implemented. So whenever error happens, what the system should do, accordingly behave it. Rather, assume failure already happened and process it like a failure. Okay. Now, all the source service will implement this behavior is nothing but circuit breaking behavior. All the source service will implement this circuit breaking behavior. Everybody implements. So as an outcome, there is no further calls happening to the destination service. No further call goes to destination service. Accordingly, destination service gets time to recover. Okay. So accordingly, destination service gets some time to recover. And once the recovery happens, it starts processing properly. After recovery, it's back to normal. After recovery, it's back to normal, and then other source service will start calling the destination. So when you're discussing circuit breaker behavior with anybody, this concept explaining is the core purpose and everything for that. Okay, how basically the mechanism works. This itself is circuit breaking, and it's like electric circuit cut kar deto, right? You just cut the wire and then flow will not happen, and later you join the wire, flow will happen. That is what is a circuit breaker. Okay? So don't call, and after some time patch it, and then it should automatically work. Okay? So guys, this is the basic circuit breaking mechanism. Are we clear with this, guys? Give a quick thumbs up. First, you should know the reason also why it is required, because service get will just not come back again. So it is required. And then circuit breaker, how it works. Okay, fine. Guys, now understand there are a lot of technical things into it, how it is implemented. So that we have to now think, okay, how it can be implemented. There are a lot of technical complexities into this. So let's focus on it one by one. Good, everybody. So concept is clear. Now moving towards implementation of this. So first of all, देखो, we have one major question. How does the source service realize that destination service is not behaving properly? Okay, so that is the main first problem to solve here. We are saying here, okay, fine, destination is unhealthy, but technically, how will source know that destination is unhealthy? How will source identify that destination service is not performing? Okay. So there are several ways to interpret it. One of a standard way which is followed by majority of the projects is something like this, and you stick with this during your interview time as well. So firstly, if you are getting success or valid failure, in both case it means end service is doing good. Even if valid failure is coming, means they responded back with a failure. We already know so much of error handling, 4xx. There could be a number of reasons for failure. That service is properly processing and telling you failure means it is in good shape. So both these two things means it's success. It's fine for us. If you are getting a success response or a valid failure response, we can simply say this service is doing good. Only our problem is happening is if we start getting timeouts. So if we start getting this timeout, that means, okay, it's a problem. Okay. So that means step number one, we have to consider here if we are getting timeouts from destination. And now, how many timeouts? If one is coming, then should we assume? No, it should not be like that. You observe some data. Okay, previous 10 requests you have given, and out of that, 4 requests are timed out. Means that there is something wrong with that service. How can 4 requests time out from 10? Now you define this. Should it be 40%? 4 requests means 40%. Or should it be 50%? Or should it be 60%? Or should it be 20%? Configurable, right? So you can now define out of the past n number of requests, how many requests have actually been timed out, and as soon as that number hits, you can assume that the service is not good. So simple logic. We will depend upon timeout behavior. If we are getting timeout from that other service, so automatically based upon some threshold value, we can say, okay, so in the past 10 requests, 4 requests are timed out, means there is something wrong with the service. Now I will not call them anymore. This is what circuit breaker identification process, whether destination is up or not. If we are getting a timeout for some threshold value, after that we will stop calling this guy. Okay, so that is what how it interprets. If we are getting timeout from destination, okay, for some set threshold, okay, what does this mean? Threshold. Okay, say from past 10 requests, let's say 4 are timed out, and you define this 4 number, which is nothing but 40%. 40% are timed out. That means destination is not doing good. Destination is failing. Okay, so agar if less than 4 is there, so no problem, we will still keep calling. But if 4 are failing, 40% are failures, so it doesn't make sense to call. Give the time to recovery. Okay, this is how it is. Fine, that is one point to observe. Now look at our code and try to understand it even more further. We go to this HTTP service engine of processing service. Okay, HTTP service engine of processing service. Just see, this is the method where we are doing that API call to the destination. Okay, I've done one change here, guys. Whatever we demonstrated that in PayPal provider service REST client using with connection pool, I have applied the similar thing in the processing service also. Okay, so rather than using Spring Boot related builder and from there trying to build it, even though we are not dropping connection, it works. But yeah, it's a good practice to have a proper connection pool for making calls. So even in this place for processing service, I've just added in app config that other bean which creates the connection pooling and all that. REST client is prepared accordingly, and we are injecting that here. Okay, so we are simply injecting that here. Okay, that's fine. Now moving on further. Okay, coming back to our topic here, just see in this code, how do we know that it is a timeout? Now code wise try to observe. We understood the concept part. Okay, when a timeout is happening, and if it is more than this some value, then we will assume okay, service is not good. And what do you do when service is not good? You do this above thing. You stop calling it. Rather assume failure already and process it like a failure at your side. Okay, fine. But now let's see code wise, how do you really know whether it's a timeout? Okay, observe this method, make HTTP call. When timeout is happening, we know that it is two things, either this condition or this condition. So from method point of view, timeout mechanism is simply you are getting this condition or this condition. While implementing error handling, that is where we implemented it in this manner, so it can even benefit during our circuit breaker mechanism, what we are doing is, whenever timeout situations are happening, we are throwing exception. And only for timeout situations we throw exception. For remaining thing, even valid error response is coming, we are returning a proper response back. Okay, so we can confidently draw a conclusion here that make HTTP call, whenever this method throws an exception, that means destination service is not performing good. And guys, circuit breaker uses that for interpretation. Okay, so we will see how to apply that code, but from the logic perspective, when this make HTTP call is happening, internally, if any exception is thrown from this method, circuit breaker mechanism is going to come in picture and it will start counting that as an error. So initially 0, if first exception comes, it will say 1, and then 2, 3, 4. It will go till this threshold which you have set up. As soon as the threshold happens, the behavior is going to be different. Okay, that's it. So two things you need to understand. How will source identify destination is not performing good? First thing is, yes, we need timeout. But code wise, when you look at it closely, how do we know whether it is timeout? Is you are throwing exception there. So that will be our way of interpreting it. Whenever this method throws an exception, circuit breaker will assume that failure has happened and it will try to track those failures, how many such failures are happening, and it is crossing the threshold which you have defined as a developer. If it is crossing that, circuit breaker mechanism will work and you will not further call the third party service, whichever you want to call, right? So that's the second thing you need to understand. Okay, how circuit breaker will do. The method where you are making external call, okay, when that method throws exception, then circuit breaker logic counts it as a failure and increments it every time exception is thrown. Okay, when this count reaches threshold value, failure threshold value, then circuit logic triggers, which simply is don't call destination service, rather assume failure and process accordingly. Okay, so guys, this is what it is. Team, everybody clear with this? So approach is simple. Timeout, but how do you know code wise throwing an exception? The circuit breaker says your method throws exceptions, I will assume a failure and I will start counting it. So you need to be careful. Unnecessary exceptions if you throw, circuit breaker will count even that, right? Code hai bhai. It's not with AI intelligence. You have to write everything properly. In future, maybe you can just give code and now they can analyze which is actually like that. But for now, though, coding wise, we have to take care. Okay, fine. Okay, now let's go ahead implementing this. And then we will understand how it works. Okay, so still how they have implemented circuit breaker inside, that is very interesting. Okay, so but parallelly upon code karte, so we will do some coding and then we will understand it internal working also. Okay, dekho guys, status is something very important. It is reflected in almost everything. PayPal has a status cycle for payment, we have a status cycle, right? Like that, even circuit breaker mechanism has certain statuses. Okay, and it uses these statuses to really execute this logic, like when to call destination, when not to call destination, and for how long not to call destination. So it's a logic in itself, it's a system in itself. So circuit breaker uses CB, let's say circuit breaker uses, okay, some statuses, okay, statuses for executing its logic. It has simple three statuses: open, closed, and half open. Half open. Okay? For now, let's not get into how internally it works. For now, we will start with our coding, and as we are seeing it further, then we will understand how it internally takes care. Okay? Chalo, fine. Let's get started. So it includes a lot of configurations, some annotations we have to use, some property file changes needs to be done. So all these mechanisms are there. So we have put all that in a central document, and I will be sharing this document also with you. So all the coding related tips, you can go to ChatGPT and explore from there. You will get some options of doing that. So all that information. But for ease of access, we have summarized everything in one document. Let's say this circuit breaker, and this one we will be sharing with you. Okay. So a few things you need to understand again here. Spring Boot team or Spring team, they have provided Spring Cloud as one of a category in which very much tools required for microservices are available here. Okay. So if you go to Spring Cloud, project Spring Cloud, okay, just observe. Under Spring Cloud, there are so many other things. Just see, circuit breaker is also one of the thing. Plus, a lot of other capabilities are there under Spring Cloud. And observe the definition here. Spring Cloud provides tools for developers to quickly build some of the common patterns in distributed system. Like multiple things are there: configuration management, service discovery. Even when we discuss about service discovery, Eureka and all, that is part of Spring Cloud itself. Next, circuit breakers and much more logics, okay, which will be utilized in microservices, are available as part of this one. Okay. So Spring guys have given a separate project here called as Spring Cloud. As part of that, there are a lot of tools or softwares or libraries. These are nothing but, again, some projects, dependencies, jars. They are calling it as tools because it's again some code which will do certain activity. So in a general term, we can call it as a tool because it is doing some activity, functionality for us. So what they are saying is Spring Cloud project is providing some tools which are required for developers to do some basic day-to-day activities for distributed systems. And then some of these activities are like this. Circuit breaker is one of the activity which we can achieve using Spring Cloud. It's just kind of grouping things together, how they have grouped it naming wise and all. So just be aware. Okay. Spring Cloud offers tools. Spring Cloud offers multiple tools which we can use while working with microservices and building distributed systems. What is distributed systems? The code is running, the software is running in multiple machines, maybe on the same network or different network. So distributed, it is all executing in different machines at big scale, right? So yes, this is what it is. Spring Cloud offers multiple tools which can be used for working with microservices and building distributed systems. And circuit breaker is one of the project under Spring Cloud. Okay, so circuit breaker is one of the project under Spring Cloud. So accordingly, some POM dependencies are available. Okay, so far we have focused on maybe just one of the dependency. Let's observe here. Maybe something like this dependency tag. Whatever dependency we have added, we added this kind of simple one dependency tag in our pom.xml. But now we need to understand there is this BOM configuration also, bill of material. Okay, this kind of configuration is also available. Just observe Spring Cloud dependencies. What they have done is some kind of software versioning they have grouped together. Okay, so for example, just say if you scroll down here, Spring Cloud, I'll paste this URL in our session notes. Okay, guys, keep the focus here. So if you scroll down through Spring Cloud, what they are saying is, depending upon which version of Spring Boot you are using, they gave a corresponding Spring Cloud dependency. So for proper version management, under Spring Cloud, there could be so many other sub projects. There will be a version cycle for them also. So in order to simplify this version tracking, what they said is, depending upon your Spring Boot version that you are using, you use a corresponding BOM configuration. This is nothing but BOM configuration, bill of material. So they created a BOM configuration called as Spring Cloud dependencies. And depending upon Spring Boot version that you choose, accordingly you can choose the corresponding version of Spring Cloud. So what does this mean? In your project, even though you might be using multiple of this, let's say Spring Cloud Circuit Breaker or Spring Cloud, any other configuration, you don't have to deal with version numbers at every sub project level. Version number will be managed one for all of these sub projects. So just be aware, some versioning is organized in this manner. So that is the reason, if you look at this POM configuration, when we are defining it here, we don't specify any version. Whatever Spring Cloud related dependencies you have, for that it will rely on this, and based upon this version number, it will go here and check that, okay, so this version number is compatible with whatever Spring Boot version we are using. Accordingly, the libraries of that, let's say Spring Cloud Circuit Breaker, is going to come to us. So nothing but just understand, they have organized versions properly. So you don't have to track individual sub-project versions. Every project is a separate coding project itself now. But you don't have to track versions. And all these projects, they are not directly tracking against single Spring Boot application. What they did for all the cloud projects, they are tracking with the Spring Boot as Spring Cloud dependencies. Internally, if you set this, they will give you access to all of these as well, right? So currently, our Spring Boot application is what? Go to pom.xml of processing service. We are using Spring Boot 3.4.2. So we belong basically here 3.4.x, which is nothing but here 2024.0.x. If you click open in a new tab, you will get furthermore details as well. Okay, 2024.0.1. Just see, as part of this, all these Spring Cloud related sub projects, what kind of fixes were released as part of this version 2024.0.1. So kind of every info, it's an open source project, so we can check all this information online as well. And in the previous version 2024.0.0, okay, they released what all fixes across all of their sub projects. So kind of version tracking is easy. So you can pick basically any of this stable version, because 2024.0.x, this is what they said, 0.x, they are all compatible with Spring Boot versioning 3.4.x, and we are also using 3.4.x. Okay? And sometimes backward compatibility will also be there. So in case you use this or this, sometimes that might work as well. But try to choose the one relevant to your Spring Boot versioning. Okay? So guys, this is what two changes we are talking about. So we have to define Spring Cloud Circuit Breaker configuration. Okay, देखो, point is this circuit breaker is implemented using this resilience 4j library. Just it's a name of the library, that's it. ठीक है, so circuit breaker is implemented inside resilience 4j library, which we can utilize. Just be aware of that. ठीक है, so they have written circuit breaker logic is available in resilience 4j library. So just be aware of that. Resilience 4j library. So we take, if in interview they're asking, okay, which library you need to have. So circuit resilience 4j, in that circuit breaker code we will be getting. So just be aware of this name, resilience 4j. Fine. And versioning, how it is managed, we utilize Spring Cloud level versioning, where as a BOM file, the configuration is available, and that is what is available here. Okay. So two things we understood. Circuit breaker resilience 4j is where your circuit breaker code is going to come. Okay. Circuit breaker logic or code is available there. The second thing we aware Spring Cloud BOM does version management for all Spring Cloud projects. So that is where we don't need any additional version to be specified here, but it will rely upon this one for working. Okay, two things we have understood here. Furthermore, you can do some clicking here and reading, okay, what is there. You'll get some more clarity about that. Okay, I'll even paste this as part of this, so you'll get a view of that. Okay, that's fine. That's second observation. Let's go. Furthermore, internally, for operation of resilience 4j, it uses Spring AOP module. Okay, Spring AOP. Okay, maybe some of you might have heard this term earlier, aspect-oriented programming. Okay, let's understand this concept. This is really interesting. So that is the third thing. Okay, resilience 4j, circuit breaker with resilience 4j utilizes Spring AOP related configuration, which is aspect oriented programming. Okay, what is this aspect oriented programming? Let's understand the simple thing. Let's say in the code, here you have written one Java class, let's say class 1, and this is class 2. Class 2 is having, let's say, method M2. In general, object-oriented programming, you get somehow reference of class 2 using new operator or string dependency injection, but you would get, let's say, obj ref. Somehow you would have a reference of this one. Okay, class 2. Class 2, obj ref. And then what you do is obj ref dot M2. So what is the expectation? So let's say your code is executing. Think like a CPU. We discussed one process, right? How to really think about it. So what do we know is when you are executing this code, it goes to class 1. It is executing from this place. As soon as this M2 is called, we reach from this place to here, execute this, and then reach back here and resume with regular flow. This is how our entire programming is, right? Okay, aspect-oriented programming says what? Okay, it is very interesting. Before you start executing the logic of this one, you run some additional logic before and after. Okay, this is what, run some additional logic. That's it. Means from coding perspective, you are assuming you are simply calling M2 method. Coding wise, you will still do that only. But when you are calling M2 method, internally Spring takes over, and before it calls the M2 method, it runs some logic. And when response is coming back, rather than directly giving to you, it is also controlling that logic. This kind of programming is nothing but aspect oriented programming. You are writing your business logics and assuming it should directly work. In between, some code pieces will be executed. That's nothing but running it as an aspect. Okay, so what is aspect oriented programming? Don't so in between inject code. Before and after the method processing, code is injected. So that kind of programming model is nothing but aspect oriented programming. So accordingly, now circuit breaker mechanism utilizes this concept. Even though now, let's assume, let's go back to our code, HTTP service engine. Even though make HTTP call is called, let's say, from one place when we do get order. Just think about it. We will be enabling the changes in such a manner that HTTP service engine is calling this make HTTP call. Okay. However, before the make HTTP call executes, Resilience 4J is using aspect oriented programming to run some business logic. And after this method execution completes, it is not going to directly reply back with a response here. It will do some additional logic processing at that time also. So that is what, once we implement circuit breaker in our mechanism, we will need this additional capability. So before method call, after method call, we need to run some logic by Resilience 4J. Okay, why do you think it will be required? That's what, for understanding the end-to-end execution of how circuit breaker mechanism works. Okay, for now, let me just give you a glance why this advantage is going to happen. We said the concept behind circuit breaker. What is that? The mechanism works something like this. Whenever exception is thrown, the method you are making, when it throws an exception, circuit breaker logic, okay, counts it as a failure. What is going to happen now? This is interesting part. Observe, it will again change your discussions about exception and global exception handler. Okay, right now what we know is we are calling simply this method. If this exception is thrown here, as of now we know that it goes to the global exception handler code. But if you implement circuit breaker logic, it will not go to global exception handler. Circuit breaker is going to catch that exception. Nothing but before calling this method, after calling this method, circuit breaker is wrapping some logic. So what is going to happen? Whenever this exception is thrown, circuit breaker catches it. And circuit breaker says, hey, so you guys have failed. Exception is coming. Let me increment the failure count. They need to execute business logic. That is the reason before the method, after the method, they are integrating logic. Let's say second time you are calling this method. Circuit breaker says, okay, let me see what you guys do in the method. Again, you throw exception. Circuit breaker says attempt 2. Now attempt 3, attempt 4. Okay, 40% failed. What circuit breaker says? Okay, fifth time you call this method now. So what we are saying, aspect oriented programming, before you call the method, certain logic will be there. After your method execution, certain logic will be there. So if 4-time failure has already happened and you're trying for the 5th time, now circuit breaker says, before your actual method is called, circuit breaker is checking, hey, already 4 times failure has happened. 5th time you want to call that method. Circuit breaker says, I will not allow you to call that method. This is where it is interesting. Aspect oriented programming is required. Circuit breaker say, okay, no, I will not allow you, because 4 times you said if there is 40% failure, don't call third party. So in this place, the logic which executes before this method, for initially it allowed to call the method and you are making the call, but every time it is failing, so it is incrementing it, it is tracking it. As soon as the count hit 5s, circuit breaker realizes now we should not call third party anymore. How does circuit breaker not call third party? Circuit breaker simply does not call this method of M2. Circuit breaker says, okay, you tell me another method about, we said, right, you have to assume it like a failure. Circuit breaker says, write a failure method for me and tell me where is the logic for failure method handling. I will directly call that logic. Very interesting concept. You are assuming that you are calling the destination, and that's how you have written the code. But as soon as you put circuit breaker mechanism, the behavior becomes different. Before your methods are called, after the method is called, Resilience 4J is using this AOP related concept to run additional logic. And that additional logic is tracking this execution, whether to really call this method, or if you are in a circuit broken state, then you should straight away call a failure handling method. And here you define whatever failure mechanism you want to take care of. And that is how it will skip this method call completely. For achieving this kind of behavior, aspect-oriented programming is required. That is where Resilience 4J will utilize this aspect-oriented program. So if everything is fine, you will call M2 only. It will call M2. But if the circuit problem is happening, it will call this one. And now it depends what logic you're writing here. Accordingly, failure handling is going to happen in the system. Okay, guys, is it clear? We will be coding this and debugging. You will get more insights on that. Right, guys, are we clear with this? Okay, but yeah, very interesting concept. You're calling a method, but something else will be called inside. Circuit breaker, aspect oriented programming is making that possible for you. Okay, very good. Chalo, 4th term we understood here. Nice. Let's go back, guys. Let's go back. So 4th term we understood here. Interesting. So many concepts are there. IT mein, right? First, circuit breaker logic is available in library Resilience 4J. Resilience 4J has some more things also, like retry mechanisms libraries are also available in Resilience 4J. Okay? We are using circuit breaker library code of Resilience 4J. Next, all the Spring Cloud versioning is taken care by BOM, bill of material. Okay, so you don't have to do version management at sub project level. Circuit breaker is one of the project. Second thing we understood here. Next, circuit breaker working with like Resilience 4J, it utilizes AOP, aspect oriented programming. Nothing but, okay, before and after calling your method, execute certain business logic, or in this case, execute circuit breaker business logic. Okay, which is something we explain right now. Once we see it technically, you will get more grip of the concept. Okay, fine. That is where this comes like. Next, I think one more topic we need to understand here is actuator concept. Okay, Spring Boot starter actuator. This is the 4th dependency we need to have, actuator. Spring team has given one of the project called as actuator project, which is for monitoring purpose. Okay, what is a monitoring purpose? It's like observe what is going on. Observe. Monitor means to observe. So whenever you are running a Spring Boot application, you want to know what is going inside the Spring Boot application right now. Okay, so that is monitoring. What does it mean inside Spring Boot application? Let's see how many requests came, how many requests is processed by a Spring Boot application so far. You want to know that. Okay, actuator kind of monitoring will be required. How much is the average response time of your request? It is again additional information. Actuator can provide you with that. Okay, health related. How much of CPU currently your service is occupying? How much of RAM is occupied by your service? Or how much of free available space is there? About your disk related information. Nothing but all these are some monitoring aspects. How many successes are happening? How many failures are happening? Nothing but insights about your Spring Boot application can be observed using actuator project provided by Spring team. So if you have this, you can get into insights, internal details while the Spring Boot application is executing. Okay, and we are going to work with actuators in this circuit breaker implementation, because when we are working with circuit breaker, we need to track it very closely. We said, right, one failure happened, two failure happened, then four failure is happening. After that, fifth time it should not process. So in order to track this, how many failures happened, whether it happened successfully, whether it happened failed, to monitor circuit breaker internal state, we want to use actuator. Okay, so that is where we are going to utilize actuator in our system. It is for monitoring purpose. We will be using, okay, we will use it to monitor internal state of circuit breaker. That is where we are adding it. Once you see how it works, automatically it will start making sense that yes, it is really required. Fine, these four concepts we need to understand. Okay, so chalo, let's start making some changes to our project and see whether it is happening properly or not. Okay, so first of all, three dependencies required: circuit breaker resilience 4J dependency, actuator dependency, AOP dependency. Okay, so we are copying these three things. Copy, go to the pom.xml of where are we going to do this? Processing service. When processing is trying to call to provider, in this scenario, we will implement circuit breaker logic. Okay, so let's say we will bring provider service down and then try to call that, and then let's see how it behaves. Circuit breaker logic. So our demonstration will be processing calling the provider. So we will implement all the circuit breaker logic in processing service. Okay, first three dependencies needs to be added. So you go till the end of it in the dependencies section itself and add these three things. Okay, immediately POM is going to say, hey, what about the version information for this circuit breaker library? So that we are going to manage separately via BOM. Already for 3.4, this one is a compatible version. Okay, so 2024.0.1. So we copy this. So this is dependencies management. We need to place this after dependency stack. So guys, focus on the syntax part where it comes. So it is parallel to dependencies. Okay, so dependency management is parallel to dependency. Don't add it inside, it is a problem. Okay, okay, so chalo, we added this, and just take a look. That error problem which ID was telling, it's now gone. Spring Cloud dependencies, this one. Next, corresponding these three things we have added. Now that is our step number one. Okay, furthermore, some configurations are required. Some property file configurations are required to make the circuit breaker running. So first change is add needed POM dependencies to work with circuit breaker. Okay, so done. Okay, what is the next change? Okay, fine. We have to use certain annotations and certain code. But before really touching that code related part, we will go ahead doing some property file related setup. So these are some of the ways where you are providing configurations for circuit breaker mechanism. Okay, and we said, right, actuator is for health monitoring. So there are certain parameters. If you enable few of the parameters, based upon this, it will say, okay, what kind of data you want to see of Spring Boot application. So you can go to ChatGPT and explore about what parameters to observe in general in a Spring Boot application, and whatever configuration comes, you can enable that and do some testing later. Okay, it could be one of a exploration or a POC topic itself, working with actuators. So you can just go to ChatGPT and say, okay, how to set up an actuator, what kind of standard enable parameters required. Just focus here is we are doing this management health circuit breakers enabled. So nothing but some circuit breaker configuration we are enabling so that we can view that. So fine, that we will be doing, enabling some actuator configuration. And guys, circuit breaker works with a mechanism, so these many properties are required to make it successfully work. Okay, right now don't worry about this. This is about internal logic, counting the failures, and then like circuit breaker logic is what? Count failures. If it reaches a threshold, then stop calling destination, use error at your side itself. But the question is, for how long we should use our error? And someday we have to again call the destination to check whether it is working or not, right? So how this all mechanism will happen, like calling them, then stopping, using our error, then recalling them. What if they are failing again? Then what should we again use our backup failure? So this entire mechanism runs based upon this logic. So we will understand that when we are practically understanding how circuit breaker works. For now, we are just adding it in the code. Okay? Step by step karte hai. So don't complicate things, keep it simple. So simple things is we need to add some property file changes. Actuator needs some configuration so that you can monitor. We are enabling circuit breaker configuration there so that we can see insights about circuit breaker. Second, for circuit breaker logic to work, we need to have certain configurations of properties. Depending upon this, circuit breaker behavior will be defined. So first we will be adding these two things in our code, okay, in a property file. What we can do here is copy this, all these four things, go back to our code, Control Shift R, local of processing service, and then add here. Okay, done. This is taken care. After that, we will be adding circuit breaker configurations. All of these have a meaning. Based upon these configurations, behavior of circuit breaker is defined. We will discuss it later, but adding circuit breaker configurations, taking it with comment, so far like this. Okay, D, done. Fine. So two things we have done: POM dependencies and configurations in the property file. So let's note it down. Okay, add required configuration in properties file for actuator and CB logic, circuit breaker logic. Okay, let's try to do a Maven package and then start this application. Okay, so processing service, right click, run as. We made some changes into POM, so better to do a clean package. Console. How do I put it back here? Okay. So console. Fine. The build is successful. So even though if there are any auto configurations and all, so because of property file, because of that, everything is taken care properly. Let's start this application. So right click, run as, build clean Spring Boot :run and run it. So 2 changes are done. Spring Boot application is being started. And yes, it is running properly. Okay, Tomcat started on port 8082. Fine, this is taken care. So let's see what use case we want to test this circuit breaker logic for. Okay, so let's go to Postman. Till last week, we were coding this recon system. So we will use the same recon system for testing itself. Okay, so what we will do is launching Postman. We want to just test one API call, right? In the recon itself, we are calling get order and other things. So let's observe this. Recon service. Currently, this cron process is going to run every 10 minutes. So right now, since we are doing some testing, I don't really want to get into this scheduled based thing because we will be doing our testing via Postman, calling the method. So temporarily, I am just stopping the scheduling, just commenting it out. Okay, temp. So only for local testing. For local testing, we have commented this. So just comment it out. Otherwise, every 10 minutes that will keep running and try to work with you, right? So just stop it. So there is no split focus. So we need to test a use case for circuit breaker. Our use case is going to be something like this, recon related use case. In recon, we are calling PayPal provider service. Inside that, we are doing get order call, PayPal provider service or handler. And inside that, we are doing PayPal provider service related get order call. We would try to call that, and then in that we will do some drama. So PayPal provider service is here, PayPal provider service, and this is the code inside our processing service. Okay, so this is processing service code, and PayPal provider is like this. We will try to take one transaction and call them. Okay, chalo, let's try to put some get order call for this one. So for that, we again need to set up the MySQL. Open. Let's go to DB. One transaction we'll do, and we'll simply call the get order and see it working. Initially, let's bring even this provider service up. The recon testing we did last time, same thing we are opening. Right click, run as Spring Boot app. Let this come up. By the time, okay, this is coming. Okay, database is here, connected. Look at the transactions. Fine. 0, 10, 10, 0. Let's focus on only one. We want to test only recon related. So we need to do whatever changes. Okay, we need to test what? We need to test only for circuit breaker logic. We want to test one API call from processing service to PayPal provider. This is what we want. Okay? So in order to do that, we will be using recon use case. And there we will implement circuit breaker and check the other things. Now, in order to test these things properly, we are putting some temporary hacks in code. What is that? Stop scheduler, comment, cron config in recon service. So we can call from our Postman and then see it work. Otherwise, every 10 minutes, that guy is also going to trigger. That's a problem. Okay? Now, we know how the recon logic works. PayPal provider service, PayPal provider handler. In the recon logic, we have all of these things last week. We don't have to go through all that. But we know that every time a request is being called, finally, we update the database, incrementing the counter. If the counter becomes 3, we mark it as failed. And so that means we can test only 3 times every payment. So again, that is right now we want to test circuit breaker. We will do a lot of failures. Our focus is to test HTTP call. That's it. We don't want our rest of the business logic to deviate. Okay? So we are putting second hack. Don't update anything in the database. Second hack we are doing. Okay? Okay, recon should work for us to give us just this API call. Our focus is just to test this API call. In that itself, we will put our entire circuit breaker mechanism. So right now we want to do some hacks so that we can call this method, let's say 100 times without stopping. So you have to do sometimes this developer hack so that you can focus on your testing. Otherwise, this recon schedule will impact. After every 3 attempts, you need a new order ID. We don't want that also. So simplify your testing. That's what we are trying to do. So first hack, what we have done, comment cron config in recon service. Okay, second hack, what we are doing here in the end, but make sure you're not committing this. It should be only for your local. Okay, here we will simply say don't do anything. Okay, so let's say if true, then return. That's it. So you're not running this business logic of updating the retry count. Because of that, even though this method runs 1,000 times, it will do the same operation of just get a call and try to make a decision, nothing else. Okay, so that is fine. So we are not updating anything in DB. Just put a to do. This is temp only for testing circuit breaker logic. Okay, so we can put a similar note in our recon service as well. Recon service, here also let's put the similar note as the to do statement. This is temp only for testing circuit breaker. Fine. So we did some hacks so that our focus could be on calling get order. Let's start this in a debug mode. So this is processing service. We will stop this processing service here. We already have PayPal provider up and running. So this processing service, we will start in a debug mode. Debug as Spring Boot app. Let it happen. Are there any breakpoints already here? Remove everything. Freshly, we will set up based upon our current situation. Okay, so service is up and running. That is fine. Let's create a new order for today's testing. We can go to Postman. Create order of PayPal provider. Provider service is already up and running. So we can call a new order. Call. Okay, we got the order ID. So let's take this order ID, putting it here only for testing. What is the second temporary hack that we did? In transaction DAO, don't update DB. Both of these are temporary hacks. Okay, so we can test circuit breaker logic. Okay, so we added this order. Let's take here. We will put this transaction status in our system as 3. Whatever this provider reference that we got, we are putting it here. we don't need this error, so we can push it. Control Z. No. I want to cancel, reject changes. Okay, fine. Apply this back again. Okay, you put this, you do a save. That's fine. Delete. Next, this also delete. Okay, 0. So this is all good. Let's put up a breakpoint and let's just do a testing whether this is coming properly or not. So we go here, PayPal provider handler. Let's put up one breakpoint here, one breakpoint here, and one breakpoint in the exception box. Let's start with this simple straight thing first of all. Go to Postman, go to recon, and call this recon. Okay, thread is invoked. Let's go here. Get order from PayPal. Currently, we have not implemented any circuit breaker logic. We added only dependencies and configuration. We have not used it in the code. So we are just seeing how the current system is working. Then we will apply circuit breaker programmatically, code-wise, and then see how the behavior differs. That's what. Okay. Currently, we added only POM dependencies and we added property file configuration. Now we are testing the existing system, whether it is working properly or not. Okay. Okay, chalo. So let's go here. Okay. Lot of things happened. Finally, here we are on a success object. Peer action required. So everything worked properly. Okay. And then accordingly, we are able to return back the response. Next, we have commented the change. So in database also, retry logic. Okay. In DB also 3 and 0. So fine, DB updates are not happening. This is what I'm trying to say. DB updates are not happening. Okay. So it is 0. Okay, fine. Let's test it once more. Shoot. You go here. Okay, you got the reply. Everything is good. And then you release. Fine. Now, how the flow happens? Get order you are calling. Guys, focus everybody. Get order we are calling. A point comes in the code where we go to HTTP service engine of processing service. And this method executes. Okay. Where is this point? This point is nothing but inside the get order from 129 line number. So from 129 line number, we make a call, make HTTP call. It goes here. It reaches inside. It runs this entire business logic. If everything is success, we get the reply here. If there is any client side problem, we get a reply here. If there is any exception, not able to connect, we get it here. And that's what is the flow, right? So we have added some breakpoints to trace the flow of the system. Okay, let's accordingly test it once more. So you call, your first thread is Scott, resume. Okay, we go to the place where we are about to call, make HTTP call. Fine, then you go inside, you are calling the HTTP, and then comes, let's say you try to call it. If it was successful, it comes at line number 38 only. Failure goes to 41. So this is success. So fine, we got success. Rest of the flow is fine. So we don't need to worry about it. Okay. So comes to this line and it just continues properly. Okay. So this is a straight regular flow without circuit breaker changes. So currently we added POM dependency, we added property file, but we did not use it. Only beans are created. But to use it properly when making this PayPal provider call, We have to add some additional code changes. We have not done that. So we tested a straight flow first of all. Okay, fine. Now comes the next point. We need to add circuit breaker changes. This is our now main step. Adding circuit breaker changes while when processing service invokes this guy, okay, PayPal provider. Okay, few annotations. We have to use that annotation @ circuit breaker annotation. Circuit breaker. So using @ circuit breaker, we can provide some configuration. Okay, so chalo, let's check it out here. We have done this. The only thing is this we need to do. Okay, just observe. We need to use @ circuit breaker, where we specify okay, what circuit breaker name we want to use. Just observe it in the configuration. In this configuration, we are saying circuit breaker instance, and this is the name, payment processing service. So we created a circuit breaker configuration with the name payment processing service itself. So whatever you are defining here in the configuration, same name you are specifying here. So what is going to happen? When the circuit breaker logic executes, it will read whatever configuration parameters are here, nothing but you have defined in this property file. So you are just relating it. So what we are supposed to do is use the annotation @ circuit breaker with payment processing service, the configuration in the property file, and simply say which method you want to execute when you are not calling the third party or the external service. We said, right, what is circuit breaker mechanism? If you realize the end service is not working, don't call them. Rather, you assume it to be a failure. Now, the point is, assuming it to be a failure, then what I should do? We have to define that logic here. So instead of calling third party, technically how this is achieved is, instead of trying to call to the PayPal provider, circuit breaker is going to say, okay, I will call this method. Now you write whatever logic you want in this method. As simple as that. So what circuit breaker is saying, I will track that, okay, there are exceptions. You are not able to call the third party. There are exceptions. I am tracking all that. I am counting. I am incrementing. Now, okay, you don't want to call external service. Okay, I will not call external service. I will call a method which you define. And in this method, now you assume failure has happened. And as a developer, write whatever you want to write. So this is how a simple circuit breaker logic is. All the code is taken care by internally of tracking and using aspect-oriented programming, right? So we just need, from our coding perspective, we just need to write a method and there define, okay, when we are not calling, let's say, PayPal provider. Let's go back to our diagram. Some time ago, what did we say? In reality, what is circuit breaker? In reality, your service is always calling this service. Circuit breaker says what? As soon as you realize that end service is not good, you don't call them. Rather, you assume failure. Okay, but circuit breaker says, what is like you assume failure technically? Circuit breaker says, hey developer, you write a new method. And in that method, you assume if you're not calling PayPal provider, how do you want to handle? Whatever is going to be your handling. Generally, we will do error handling itself. Okay, not able to get response. So I will simply call that method. There you write the business logic. And using this AOP related concept is how it works. Using the AOP concept, circuit breaker is going to make a decision. Okay, 5 failures has happened. I cannot call PayPal provider anymore. So I am going to call this failure method. Now developer has to define the logic of this method. So simple, guys, only 2 things. Circuit breaker, if you want to work with, you need to just use the annotation @ circuit breaker and define this method functionality. That's it. So the name of the method is fallback process payment. We have just mentioned the name of the method there. circuit breaker logic will call it automatically whenever there is the need for that. Okay. So how to apply this in the code? Let's look at this, guys. So we simply copy this line first, copy, and we want to apply this on HTTP service engine, this method, Control Shift O, compilation problem is sorted, it is imported. Nothing but this is the place where circuit breaker aspect oriented programming will be triggered. Every time before make HTTP call is done, circuit breaker is going to do some logic processing. And if circuit breaker realized that end service is not working, circuit breaker will not call this make HTTP, rather it will call this method directly. Okay, chalo, let's see how exactly that mechanism is. Fine. So now we need to define the fallback process. Okay, fallback process payment. Let's say this method, and we have just, you have to already assume it as a failure. What do you do basically when failure happens? Currently, what do we do in the code? We have understood our entire error handling code, that a proper error code, error message should be given back to the caller. So currently, what do we do when failure happens? We throw an exception. Same way we have to do in the fallback handling also. Nothing new required. Already we thought about ki whenever third party ka timeout happens, you throw an exception with proper error code, error message. We will continue to do the same. Nothing more change required there. So that's it. We just need to define another method, fallback processing, and write the business logic there. What is our business logic? Throw exception, that's it. It's assume what were you doing in your core method and do the same thing here. Just observe. That is it. Okay, just observe. This is the fallback handling method. How did we finalize on this? How did we finalize the signature of this method? Observe that. Whatever is this method, make HTTP call, on which we have applied circuit breaker logic, we have to take inspiration from this syntax and signature. In general terms, whatever is the return type of this, that becomes the return type of this. Next, whatever is the request parameter, that becomes the request parameter here. Next, we said whenever an exception is thrown in this method, then circuit breaker knows that, oh, I have to implement as a failure. Whatever that exception is thrown, that exception also circuit breaker will pass here into throwable object. This is how method signature is formed. Observe. So what are you supposed to do? This is where you are mixing circuit breaker logic in the code. Currently, POM dependencies were there, configurations were there. We will understand those configurations and how this all thing works together. But right now we are taking one step, which is applying it into the code. Simple two things required. You need to define @circuit breaker, which uses the configuration which is available in the property file and says whenever some threshold is reached and we realize we should not call external service, I am directly going to call this method. I will not be calling make HTTP call. I will not do that. I will straight away go and call this method. Now, as a developer, you need to think, while this method is being defined, what kind of business logic you should have. It's simple. You already assume that you did not get response from PayPal provider. You will not change your business logic, right? It's timeout. Just that you don't call API, then get exception, and then you process. Rather, you process it straight away. So you're not going to make any HTTP call because circuit is disconnected. Straight away, this method will be called and executed. Okay. Second thing, whenever an exception is thrown here, circuit breaker is going to call it, and still it will give consistent this behavior. Let's test it, guys. Okay, so changes are only these two. We will try to interpret how the method signature is done, and then we will move forward testing it. Okay, so adding circuit breaker changes while invoking. Okay, so this is the method signature, and this we will be putting under make HTTP call. Let me copy this as well. Okay, based on circuit breaker logic, if we realize that destination service is down, then circuit breaker will directly invoke this method, this method, this method. Okay, signature of that method is something like this. Now we can say your return type is return type of make HTTP call on which @ circuit breaker was used. Okay, method parameter, method param1 is of make HTTP call again, and param2 is the exception, thrown by your method. Okay, so accordingly it is going to do some processing. So fine, this is how these two changes are, nothing else required. We have done the required changes, and let's just save it. Anyways, we don't need any of that request structure or exception object. Both of them are not required. We are simply going to just execute it, right? We are just simply throwing error exception itself. So you don't need to depend on any of this business logic. So simply exception is thrown. That's it. Any more changes required? I think we are done. POM dependencies, done. Circuit breaker annotation with a fallback handling, done. Property file changes, done. Okay, guys, you can monitor the health. Okay, observe here. You can monitor the health. So this is our URL. 8082 is our service, right? Recon our processing service, we run it on 8082. We have enabled actuator, so you can monitor actuator and circuit breaker on this URL. Just observe. Okay, lot of details are there, but circuit breaker related detail is available. As part of this circuit breaker, we have set up circuit breaker with the name payment processing service. It is configured in our property file, and certain parameters we have defined. Accordingly, these things are taking effect. For now, don't get into all these numbers. Slowly, as we start testing, it will start making sense. For now, you should understand is, yes, we have enabled actuator in the code, and using this URL, we enabled actuator, and in that we even enabled circuit breaker configurations to be seen by the actuator. So once we did that, after launching this URL, we are able to see internal state of our Spring Boot application 8082, and then actuator health. There we are able to see circuit breaker configuration. Okay, so we can monitor it here. So because we have enabled actuator, we can see the internal state of circuit breaker. That is what is configuration here. Okay, so here we go. We enabled actuator and can actuator with circuit breaker logic we can monitor below. Okay, guys, are we clear with this? Can we continue further with the testing? Code changes are done. Now we are supposed to test it. And then we will understand all these parameters and status of circuit breaker, how everything works. Okay? Interesting next 30 minutes will be there, guys. Please focus, everyone. Cholo, cholo, cholo. Week 7 is going on. Still new topics, interesting topics. Put it into resume, confidently present. Okay, let's go, guys. Let's go, everybody. Okay. So changes are done. We come here. Now it's just about testing it. Fine. Ignore all these things. How to test? Fine, 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 fine. Let's do some testing. Here we are on circuit breaker. Currently, service is up. Let's look at everything is fine. What is our current setup? Processing service is also up and running. Provider service is also up and running. Both the services are good. And we have added all the configurations for circuit breaker in our project also. Let's put some breakpoints accordingly. Line number 31 is already a breakpoint. If we get successful response, already a breakpoint is there. Failure, already a breakpoint is there. Getting an exception, already a breakpoint is there. We will add one breakpoint in this fallback method also to see when is circuit breaker calling this. Okay, that's it. Breakpoints are there. So case number 1, let's test a simple straight case where we are not bringing down the destination service. Circuit breaker mechanism takes an impact when the destination service is down, basically, right? But let's see how in general sense it is going to work. Fine. Let's go. Our case 1 that we are testing is both services are up and running, and let's debug with breakpoints. And CB configuration is fully applied. Let's debug with breakpoint. This is our first case of testing. Okay, fine. Our service is already running in a debug mode. Breakpoints are added. Let's go here and shoot. Okay. Breakpoint is hit. Get order called. You're about to call make HTTP call. Okay, fine. Resuming thread. You're calling make HTTP just the way it was earlier. The code is behaving in the same way, calls the HTTP. Tries to make now actual API call with this REST client. So you go here. Call is successful. You return back. Okay. You come back here and then you assume everything is success process. Means nothing changed. Okay. Nothing changed. Everything went the way it was always working. Go back to your monitoring, health monitoring of circuit breaker, and let's just see what is happening. Observe. This thing got incremented. Nothing else changed. Buffered called, right? That means some circuit breaker logic started tracking something. One API call happened. This is what the circuit breaker logic started checking. Okay, let's call it once more. Let's call it once more. Same process again. Calling it for the second time. Behind the screen, again, thread is caught. Let's go through the same process. Release, calling this method, make HTTP call for the second time. Okay, release, success response is coming. Everything is fine. 2 times we called. Let's go back here to the circuit breaker logic, refresh. Just see, buffered called is 2. Nothing but every request that we are making, Now circuit breaker is tracking it. That is the observation here. As some parameter buffered calls. Okay, fine. But our current conclusion is, okay, everything works the way it was earlier working. Just, okay, additional observation, circuit breaker is tracking our request. This is the first conclusion. Second, we tested success case. Success API call means end service is replying properly, no exception thrown. Success API call flow. That is what end-to-end it worked properly. Okay. Next, now we will try to produce a failure and see how that works, guys. Okay. Case number 2, because this is where we say there is a problem. Okay, we will bring down PayPal provider service. Then we want circuit breaker to assume that it is a failure. So when PayPal provider comes down, we are throwing exception. So let's check that flow. Okay. So we bring down PayPal provider service and trace end-to-end application flow. Let's do that. Okay. So we go back here. Processing, be careful when you do all this testing because it needs time to arrange the required information. And please be aware, currently circuit breaker have started doing some tracking. As soon as you dev tool dependency is enabled, means every time you make some modification and save, all your circuit breaker configurations will reset, right? So if you make any changes, it will become again back to 0 because it's a new Spring Boot application restart. DevTools is working, so be careful with that. While making testing in between, accidentally also if you restart this, make change and save, it will again start from 0. So be aware of that. Otherwise, you will unnecessarily lose time. Wapas say what happened. So be careful when you're doing this testing. So our second scenario is we will kill process provider service. So this is the provider service, PayPal provider service. So we are going to bring it down. Take care. So terminate. Done. Provider is gone. Currently, we have only then processing service up and running. Breakpoints are already in place. Let's try the third request now with breakpoint flow. So let's go. Okay. Shoot. Breakpoint is caught. Resume. We are about to call make HTTP call. Okay. Resume. Calling this. Destination service is down. So exception should be thrown. We already have a breakpoint. Let's see how this works. Resume. Yes, exception is thrown. Okay. As part of the previous flow, what used to happen while we were developing recon last week? Your controller advice is also not being triggered because our recon used to come, right? So our recon service in processing service, not recon service, PayPal provider handler. Here we have written a try catch. When any exception was thrown by HTTP engine, it was coming directly at line number 100, if you remember. And we discussed all that part as part of last week itself. Okay, because we have written it in a try catch. So accordingly, Java ka try catch mechanism, it goes to the nearest possible catch statement and caught there. So earlier now what was happening? When we are throwing this exception here, it used to go to the nearest try catch, which was in PayPal provider handler, and then some behavior was coming. Okay, right now circuit breaker is in place. Let's see what happens to the flow. Okay, so we are simply resuming the thread. Okay, resume this thread. Observe. Circuit breaker mechanism kicked in. Circuit breaker mechanism took that object, whatever problem you were having, internally notice that, okay, this method has thrown some exception now, means I have to do some kind of failure handling this time. And we told circuit breaker that, okay, when problems are there, when failures are happening in our system, your fallback method is this one. So it looked for this method, and then the method was available here, and then it invoked that method. Okay. And now here, whatever code you write, we are writing the code like throwing an exception itself, consistent. So now we go ahead doing that. Let's resume further. We go here, throw, prepare the object and throw. Observe, guys, the code did not directly go to the try catch. The code is now in AOP utils. What does this say? Your exception handling method was called from AOP library, aspect oriented programming library, which Resilience 4J circuit breaker was using first of all. Okay? Observe, these are big learnings. So AOP practically we saw. Okay, exception was thrown. It did not go to the PayPal provider handler straight away. It went to some AOP utility, because yes, circuit breaker uses that mechanism before and after every code it is running this additional logic. So let's write down at least this thing. What have we? Okay, conclusion thoda baad mein karte. Let's continue with further journey, then we'll make some notes of it. Fine, so this is taken care. Let's resume further. Step over. This guy's rethrowing exception. Let's see where this goes. Okay, still it is all in Spring AOP module itself. Now, kitna zyada code hai, right? Okay, from somewhere it released. Finally, it went to some code piece where we don't have even the path access. So we do a resume, and then we see, just see control from all that AOP related handling. Finally, the control has come back to our exception box. So eventually it comes here because we have thrown exception in that fallback method. If you don't throw exception, system will behave differently. So please be aware of that. In the fallback method also we have thrown exception. For that reason, something happened and the code is coming here. So depending upon how do you want to handle the fallback, okay, when third party is not called, when PayPal provider is not called, do you want to throw really an exception in fallback or return an object? Based upon that, the behavior is going to be defined. Our current code says whenever timeout is happening, throw an exception. Based on that assumption, we are writing the rest of the system. So this is perfectly fine. So let's resume with this. Okay, the object is printed, everything is okay. Let's go back to here, third API call we did, and let's try to refresh it once. Guys, what did we see here? Observe. Third call happened and failed called is 1. So now it is starting with the failure tracking mechanism. And it did a internal error handling also. It caught the exception, made a fallback method call, and there that guy has thrown exception, so it has just given it back to the previous. AOP was utilized. Let's write down bullet point conclusions out of this third experiment. What happened? Case number 2, bring down the PayPal service and invoke from Postman and invoke recon from Postman. Okay, fine, done. Next, what were our observations? Our observations were, okay, in make HTTP call, exception was thrown since PayPal provider, guys focus on these notes, since PayPal provider was down. Okay, fine. Next, okay, make HTTP call through an exception. Through exception. Okay, fine. Next, this exception was handled by circuit breaker logic and it further invoked fallback method. Okay, next. I mean, now it's developer. Whatever logic you write in fallback method, it will behave like that. You threw an exception, so it went through a exception journey. If you return a value, it will go through a different journey. Okay? So based upon the logic, of fallback method, okay, we threw exception. Okay, we noticed that value was handled via internal AOP libraries. Okay. Further, exception was delegated to PayPal provider handler in exception box, right? Try catch box, try catch block. Okay. These were our observation from execution perspective. And what do we see from monitoring perspective? Monitoring observation. Okay. Buffered call became 3. Buffered call became 3 and failed call became 1. Earlier 2 were successful and this became 1. Okay. So now we have to start getting into more deeper about this. Guys, are we clear with this? Clear with this? Abhi se movie start ho rahi hai. Okay. So now it's going to get more interesting. So be along. Okay. Flow has changed. Let's be along. Okay. Okay, good. Let's continue, guys. Thanks for confirmation. Let's continue. Okay. Now we will start doing failure, but now we need to understand how circuit breaker mechanism is working and certain parameters that we have done. Okay. Let's see. We go back to our property file, local processing service. We added a lot of circuit breaker mechanism parameters. Observe here, there is one of the parameter called as failure rate threshold. Means this is percentage, 40% failure. Okay. We are saying if 40% of the requests are failing, then circuit breaker mechanism should click in. For now, just understand that. We are saying ki out of whatever 100 requests you make, if 40% requests are failing, then stop calling destination service. This is what is this parameter, 40% failure. So if 40% requests or more are failing, then stop calling destination. Only call fallback method and go from here only. Don't make an HTTP call. That is this first parameter. Okay. And the second parameter here says minimum number of calls. Nothing but in order to calculate how many are failing, wait for at least 5 calls. So let's focus on these two parameters now. Okay. So failure rate threshold is saying 40% failures. Okay. Means if 40% of requests are failing, then stop calling destination service. Rather, directly call fallback method and continue with processing. That is what is this first parameter, 40%. The second parameter is minimum number of calls is 5. Nothing but start calculating errors, whether this 40% has hit or not after 5 API calls are made. Okay? Start calculating whether we are reaching threshold or failure threshold after minimum 5 calls are hit. Okay, some kind of logic. Let's try to see these two factors actually at work. Okay, we will do another failure. So currently how much we have tested, guys? request 1 was success, request 2 was success. That is what our current buffered call tells us. We go back here, we are into this place, we are refreshing. Buffered call is 3, means 3 requests we have made. Request 1 is success, request 2 is here, request 3 we have made, third buffered call, but it is now failed. Okay, chalo, let's now make request 4 also failed. Let's see what's happening. So we go back here. Currently, still the destination service is down itself. Still the destination service is down. We'll just replicate it and see how the flow goes. Okay, fine, let's go. So we come back here. Breakpoints are already in place. Calling for the 4th attempt, request 4 going on. Okay, we are here. Get call, resume. About to call, make HTTP. Inside the method, here you actually try to call HTTP. PayPal provider service is down. It throws an exception. Let's throw that exception. Circuit breaker sees, oh, service is down. Where this method is throwing an exception means something is wrong. Service is down. Circuit breaker logic kicks in, says, okay, fallback, you do the handling, because whenever you don't get a response, you have to do some processing there. It called our fallback method, and then, okay, it further threw an exception, which is now caught by try catch, responded. Fine. Flow number 4 has happened. We can go back here and check the health monitoring, refresh. Okay, 4. Out of that, 2 has failed. Okay. One more thing you focus here, guys. There is something called a status here, which is saying closed. So now we need to start seeing more parameters in this one. Status closed means you are actually calling the destination service. That is status is closed. Every call that you are getting, you are making it to the destination service. That is the meaning of status closed. We will discuss more on the status part. Right now, just ad hoc observation we are giving. Okay. Status closed means for every API call, you are calling destination service. That is status closed. Okay. What other parameters now you can start focusing? Here we are very much clear. Failure rate threshold is like this. Okay, which is 40%. We have said that, we know that. Let's currently check out what we do. What did we do? Request 4 we tried, and this was again failed. And the current scenario is buffered called is 4 and failed called is 4. Okay, put it there. Done. Now let's go forward. Request number 5 we are putting, guys. Now request number 5, we will again produce a fail scenario only, no changes. Fail scenario. Provider service is down. Fail scenario. Let's see. Let the circuit breaker mechanism take over the system now. Let's see what happens. Okay. So we will try this 4th one also, 5th one also as a fail scenario. Let's see how it goes. Breakpoints are already in place. You go here, you shoot, breakpoint is hit. Okay. Another failure we are trying. Next. Make HTTP call. Okay. We are inside the method make HTTP call. That means you are going to call the PayPal provider now. Again, the service is down. So it throws an exception, everything expected. Now you are rethrowing an exception here. Circuit breaker catches it, calls the fallback method, and now you are supposed to write whatever logic here. You are also throwing an exception. So it is coming here, and then your whatever code flow is happening. We tried it all again. Now go back here, refresh, observe, things changed. Let's take this into Notepad so we can have a view of this one. Lot of things changed. Circuit breaker mechanism kicked in, guys. Observe. Okay, what can we see here? First, status has changed to open. Earlier, it was closed. Now status is changed to open. Fine, we'll understand status later, not a problem. Fifth request we called. Out of that, 3 requests failed. Yeah, that is what we are trying to do here. 5 requests we called. Out of that, 3 requests failed. Yes, correct. 5 requests we called. Out of that, 3 requests failed. Okay. Next, we have set up a parameter, minimum number of calls. Minimum number of call is 5, and we have made 5 attempts. Now, what does this mean? Start calculating whether we are reaching the failure or not. So as soon as 5 is hit, it starts checking whether we are crossing the threshold or not. So if you remember, earlier this value was all 0% or -1. It was not tracked. But as soon as you have hit 5, that is the minimum number required for starting the tracking, it started calculating. And it is trying to now calculate and say, out of 5 requests, 3 requests has failed, nothing but approximating like 60% failure rate is happening. Not approximate, right? It is accurate. 5 requests में से 3 गया, तो 60% is failure, 20% is success. It is clearly telling here कि failure rate, as soon as 5 requests happened, 3 requests has failed, means from 5 requests, failure is 3. It is nothing but 60% failure. Next comes the question, is 60% failure this one greater than the threshold which we have set up? Yes, it was like that. Accordingly, it moved it into open state. This much of logic circuit breaker has implemented. Okay, let's draw some conclusions and then we will go with further experiment. Okay, so guys, observe. Lot of interesting things circuit breaker did here. After 5th failure, buffered call was 5. Okay, failed call is 3. We have set minimum number of calls as 5. Minimum number of calls as 5. So, circuit breaker checked how much is the current failure rate, percentage. So, 3 failed out of 5. So, 60% is failure. And that is what failure rate term defined. So, failure rate is 60%. Next, you compare that to what you have set up, failure rate threshold. You are saying ke bhai, it has, if it is 40% or more, if the failure rate would have been less than 40%, it would still continue to be in the previous situation only. But now the behavior is changed. Failure rate threshold. Okay, so next we have set failure rate threshold to be like this. Since 60% is more than our set threshold, so circuit breaker changed state to open. Okay, what happens in open? But behavior change, we are just trying to observe what is happening. We will interpret conclusions as we are seeing further things. Okay, So fine. So यहाँ पे आ गया. Now देखो, there is this one more interesting thing also. Okay. If I refresh this right now, observe current status is open. Let me copy this also. Current status is open. Change status to open. Earlier it was, I think, closed. Yeah, closed something. Now I'm just refreshing this. We are in open state, refreshing this. Just see, status is now half open and all of our data is reset to 0. Means circuit breaker is still behaving in a certain manner inside. That is what we need to understand, how the circuit breaker mechanism is working. That's what we are trying to go. But we did not do anything. We waited for some time, refreshed the health, and now we have another observation. Let's write it down. Next observation. Okay. So we waited for some time and refreshed the actuator to check latest state, and we have a modification. Status is half open. Okay, and rest of the data is reset. Rest of data is reset. How did this happen? Right? Again, we have done that. Circuit breaker is working based upon the configurations which we have said to the circuit breaker. What is that? Let's go to the property file. Okay, you go to the property file, local in processing service. Just observe wait duration in open state. Observe this. Wait duration in open state is 60 seconds. Nothing but we are telling to circuit breaker that in open state you should wait only for 60 seconds. Second, this one, automatic transition from open to half open state is enabled. Means we are telling circuit breaker, whenever you go in an open state, wait there for 60 seconds. After that, you automatically change from open state to half open state. Two more parameters we understood. That is where it behaved like that. Why all this movement and all is required, we will understand. Right now, we are just analyzing what is going on. We will interpret the meaning and conclusions in some more time. But right now, we are just trying to understand why circuit breaker is working like this. It's kind of curiosity. Okay, why it is happening? There are reasons. We have defined those configurations. What we are saying is wait duration in open state. Nothing but whenever circuit breaker is in open state, it should stay there only for 60 seconds. So by the time we were making that notepad notes and discussing these things, it was more than 60 seconds automatically. And after 60 seconds, we refresh. Even we have this automatic transition from open to half open is enabled. So it is now moved into this one. So let's take this as observations. Why it happened like that? Okay. We set up like this. And we have this one. Automatic transition. So when failure threshold crossed 40%, then circuit breaker changed to open state. However, we have above two configurations, these two configurations, where circuit breaker stayed in open state for 60 seconds and then automatically transitioned to half open state. This one. Okay, so chal gaya. But now what is the purpose of this open, half open? Fine. Closed ka we were seeing okay, when the status was closed, every time you were calling that other guy destination. Now what is different with all this? What is the purpose of all this? Let's understand it one more level deeper. Okay. So guys, now we are understanding the big picture of how this circuit breaker takes the full effect. Okay. So guys, everybody, please put your entire attention. Dekho, right now we have not even seen how is the behavior of open, and we are already in a half open state. So we will be restarting our Spring Boot application and producing the cases right from the step number 1 again. Okay. So guys, everybody observe. We are restarting our application again. How do we do that? Space, save. Spring Boot application is being restarted. Okay, it is up. Go back here. Refresh. Status is closed. Guys, this is the beginning state. Application, guys, focus everybody. We are now connecting the entire system together. Full detailed understanding will come of all these statuses and how the movement is happening. Whatever we were discussing right from beginning till now, we are demonstrating everything, how it is working with circuit breaker. So please put your full attention. Initially, the status is closed. We can put it into a diagram also as we are going through. Okay? Initially, the status is closed. Fine. Here we are. We put it here. Initially, the status is closed. Okay. Next, our PayPal provider service is down. So I'm not bringing it up right now. Let it be down. Everything we will track it as a failure and see how the rest of the system behaves. Okay. So system is closed. Next, PayPal provider service is down. Okay. So we have only processing service up. This is terminated. PayPal provider is terminated. So it is down. Only this is up. Fine. Next, make the first API call. All the breakpoints are in place. Making the first API call. Breakpoint is hit. Next, get call. You're about to make HTTP call. You are calling that HTTP now. Here you will call at line 35 code. Destination service is down. Exception is thrown. Circuit breaker caught it, telling that it is failed. You threw an exception, came back here, returned back. Fine. Go here, refresh. Okay. Tried one time, failed one time. Failure rate is not being calculated right now. It waits for 5 attempts, then it calculates it. Minimum 5. Okay. Next, this is the first observation. We tried run 1. So it is fail 1. Okay. Next, go run 2. Again, it should be a failure. So what we will do is, rather than fully testing it, we will skip the breakpoint, because same flow is going to happen. So we will just skip all breakpoints because nothing is going to change. Everything will be the same. So I'm skipping all breakpoints and just doing end-to-end observation. Okay. So calling it for the second time. Go. Come back here. We tried for the second time. Just see. Call to, fail to. Let's call it for the third time. Okay. I think since we are doing this round of testing for first time, let every time go with the breakpoint. So you will see the difference, how the circuit breaker behavior is changing. Okay. Enabled the breakpoint. Let's go. Third time. Breakpoint is called. About to call make HTTP. Calling HTTP. Calling the third party. Got a failure, exception. You're throwing that exception. Circuit breaker is catching it. Calls the fallback. Okay. You threw exception. It comes back to PayPal provider handler. You returned back. That is nothing but our next attempt. Okay. So refresh, fine. Tried 3 times, all 3 failed. 100% failure rate is going on right now. 2 more times we need to try. Then it will start calculating and have some behavior. Okay, chalo, let's go. Now we go back here. One more time, 4th attempt. Go here. Breakpoint is called. Breakpoint is called. 1, 2, call, exception, circuit breaker tracked it, you threw an exception, came back here, done. Go back. What's the behavior here? 4th attempt we did. 4th attempt did, all 4 failed. 4th attempt we did, all 4 failed. It has not calculated it because minimum number of requests should be 5 in order to calculate failure rate. Once it calculates, then it will compare with this and then decide should it be continued to closed or should it be something else. But right now you should know this one thing. Currently what is happening? Every time while it is in closed state, it is calling HTTP service engine dot make HTTP call, which is making a REST client call to PayPal provider. Nothing but putting in short, when the status is closed, it calls the other service. That we can now practically demonstrate after trying it so many times. So it calls external or destination service when status is closed. That is what is happening. Okay, chalo, let's continue further. Let's continue further. Okay, now 4 times we have already done it. We need to be fast, guys. As soon as 5 happens, it will calculate the threshold and it will see whether it is greater than 40. If yes, it will change the status into something else. Okay, after that we just have 1 minute of time to do the testing in open state. Okay, so just observe, we just have 1 minute to test, so we need to be really focused. 1 minute wait time we have set up to 60 seconds only, so within 1 minute we have to do the testing. So chalo, as everybody focus, what are we testing? I'll re-summarize it. 4 requests we have made, all the 4 has failed. We try once more, 5 it will happen. It will calculate that all 100% failures are there. It will change the state into open. As soon as this becomes open, we have only 60 seconds to test what is the behavior of the open state, because after that it will move into half open state. So now we are at that place. Okay, chalo, let's test. So we need to be fast. 1 minute ka full focus is required here. So here we go, trying a failure for the 5th time. First of all, we come back here, Postman, 5th we are calling for the first time. Here basically same flow should happen, nothing should change. You're about to call make HTTP call, go, make HTTP call is called here. Now you will try to actually call PayPal provider service for the 5th time, and you are failing for the 5th time, and then you're throwing an exception here. Okay, circuit breaker caught it. Circuit breaker is now calling callback method. Okay, very good. Now you threw an exception which went back to PayPal provider handler. You repeated it back. Now you come here and then you refresh this. Okay, what did we say? Yes, all that happened. 5 times tried, 5 times failed. Status is now open. It calculated 5 attempts means 100% failure. Everything is failed. More than 40. Status is open. Now let's call one more time, the 6th time, and see the behavior, what happens. So you are calling it. Okay, guys, observe the behavior now. It is an open state. Get order. You're about to call make HTTP call. I'm doing a resume. Observe. It did not call make HTTP. The complete method is just bypassed. It did not hit this breakpoint. It did not come to this exception box. Rather, directly it came to the fallback. And now you continue with the fallback. It skipped make HTTP call completely. Means destination service is not called. That is what has happened. So you come here, you go here, you refresh this. Just observe. Okay, again 60 seconds was done. So it moved into this place. Okay, एक और बार करते हैं थोड़ा सा more detail. So guys, observe. ठीक है? What we will do is, for this time testing, we will change this to local processing service. Instead of wait duration for 60 seconds, let's make it 3 minutes, 180 seconds. Okay, save. Today, you need to do this kind of experiments and get control on what is going on working with circuit breaker. 180 seconds long. Okay? So now we have reset everything back from zero. But we took that learning. Open में जाने के बाद it skipped make HTTP call. That was interesting observation. Let's again produce it. Okay? Initially, we will do failures again. So what we will do is skip all breakpoints. So that same thing we are testing like multiple times. So we will skip all breakpoints and let's just try to produce one failure. One time tried, one time failed. Second, 2 times tried, I removed all the breakpoints. 2 times tried, 2 times failed. Next, third, 3 times tried, 3 times failed. Fourth, 4 times tried, 4 times failed. Okay, as soon as 5 happens, it will become into closed. Now, one more time, let's observe this very closely. We are enabling the breakpoints. Go 5 times. 5th time, called. Breakpoint is hit. Resume. You are about to call make HTTP call. Resume. You actually call make HTTP call. Here now you will call REST client, third party, the Stripe payment provider method, PayPal provider method you will be calling. And then you go. It threw an exception, means you tried to attempt, it threw an exception. PayPal circuit breaker caught it, called the fallback. Next, returned back. Okay, this was the 5th attempt. You go back here. Now you refresh. All the calculations happened. It is now in open state. 5 times tried, 5 times now it is in open state. Now we will call again. Check the flow difference. Call. Breakpoint is hit. Resume. Next, you are about to call make HTTP call. Resume. But it did not call make HTTP call. It went directly to fallback, means bypass happened. And now you resume. Here you are throwing exception. Now it comes back to this place, resumes back. Okay, next, you're back here, refresh. What is happening? Not permitted calls. It is trying to now calculate, okay, not permitted calls means one call I did not make to the destination service is not permitted calls. Bypass happened and fallback happened. Let's try once more. We have 3 minutes window here. You shoot it again. Okay, your thread is caught again. Go here. You're about to call make HTTP, but you don't call make HTTP. Circuit breaker says no, jaane nahi dunga. System is down. You directly go there. Traffic police is directing you. Okay, go to the fallback method straight away. Okay, fallback method throws again exception, comes back here. Okay, second time you go back and you refresh. Number of calls not permitted. Not permitted calls is 2. Okay, that means while you are in open state, you are not calling destination service. Simply fallback handling is taking over. Now what we will do is we will simply put skip all breakpoints and just do some calling here. 3, 4, 5, and let's go back here and try to refresh. Just observe, 5 calls not permitted. That means while you are in open state, you don't call destination service. You return everything from the fallback method. Nothing but your service itself make a decision. Okay, it is not going to work. Unnecessary calling them. That is what this is. Now you can keep calling is as long as it takes. Okay, and the point is it will be just stopping all your calls. Even if 1,000 call happens, it will not call even once for them. Every time it is going to return from fallback itself. Guys, are we clear with this? Practical demonstration with thread, full control, full clarity, right? It is not going inside make HTTP call. सीधे fallback जाता है. Why it is happening? Because it's in an open state. Open state. Why did we go to open state? We discussed. We saw that a third party is down. We gave you chance for the threshold. It is more than 40% failure. So we cannot go further. सीधे fallback. Fallback. चल रहा है, चल रहा है, चल रहा है. Good stuff. Very interesting. That is what is AOP mechanism also, guys, right? Aspect oriented programming. You're calling destination method, but वहाँ पे traffic हवलदार है. It's like go from that side, brother. That's what is just redirecting our flow while it is in open state. So I think we can take some notes about this. We practically saw the behavior. Okay? And then we will dig much more into half open state. That's our next target. But now we can go to the next step. We were in closed state. And then we were trying to make request. Okay. And then what we discussed was the failure rate. Okay. If the failure rate is more than threshold, in our case, yes, it was 100%, which is more than 40%. So if this condition is met, after that, our state was changed from closed state into open state. We went into this state. Okay. So the transition was like this. If the failure rate was more than this, then we went. When did we calculate failure rate? Based upon minimum number of parameters. So we can take a note of that also. We calculated it later. So not like right from first request we are saying it's a failure. Okay? So we calculated it later. So minimum number of calls. Then we calculated. So we can take it and put it here. So we calculated it here. Minimum number is 5. We calculated failure rate after 5 requests. And then it used this below logic of failure threshold. Okay. Let's put this down. Let's put it here. And then it moved into open state. Okay, fine. Now what is happening in open state? Closed state where you're calling the destination and remaining flow is happening. Okay. If exception comes, then the fallback happens. So we can see that. Okay. You call destination. If exception comes, then circuit breaker tracks it, calls fallback method, and increments failure count and continues with the flow. Yeah, that's it. In this flow, this is happening. If exception comes, so first of all, you call the destination service. If exception comes, then circuit breaker tracks it, increments the count, and calls the fallback method. Ye pura ka pura logic executes. It does that incrementing till the time this logic is hit. As soon as this logic is hit, it is moving into open state. What is the speciality of the open state? Open state means like, देखो, circuit is open. Imagine like an electric circuit, there is a wire. Now wire is open. If the wire is open, current cannot pass. That is where this naming is coming. Closed means wire is connected. If the wire is connected, electric current can pass. If the electric current can pass, means make a call to the destination service. That is what is pass electric current. Circuit is an open, means current cannot pass. Open circuit, current cannot pass. If current cannot pass, means don't make API call. That is where the circuit breaker naming is coming, and all these statuses are named like that. So open means wire is broken, current cannot flow. Current cannot flow means don't make API call. That's what it is. So when you are in open state, it actually means you don't call destination service. Awesome. You don't call destination service. Okay. Rather, directly call fallback method and process. Okay. Next, we notice that this is being incremented. Not permitted calls are being incremented. This gets incremented. Means not permitted to make external calls. So at least we have tracking how many calls we did not even call the third party. Okay, guys, now यहाँ पे एक थोड़ा interesting catch is there. Okay, very interesting catch. Sometimes this happens in system, and you should know that it is perfectly fine. It is okay to have it like that. What interesting catch, guys? You have two services: processing service, provider service. Let's say you were earlier in closed state, now you moved into open. When you are in open state, you don't call third party, don't call destination service. We discussed till this point. Yeah, we don't call destination service. Rather, you directly call fallback. Directly call fallback. Okay. Now we know this factor. You stay in open state. Currently, we have configured as 180 seconds. That means for 180 seconds, it will behave like this. Directly from fallback, directly here. Now, the situation is very interesting. What if, while you are waiting in open state, PayPal provider service comes up? In that, what will happen? Let's say you said instead of 180, you are saying here 5 minutes. 5 minutes, if you are in an open state, means you are not even trying to call PayPal provider. You just take fallback, assume everything has failed, and provide it like this. Just imagine if that window is 5 minutes. And the question, maybe PayPal came back in the first minute itself. So for 4 minutes, PayPal provider was up. But for all the requests, you were responding with failure for 4 minutes of time. You need to be aware. It's an aware decision. Okay, yes, we want it like that. It's not a bug or misbehavior. You have to decide the parameters very carefully. That is where, how much should be your failure rate threshold? You have to be very careful with that one. After seeing that kind of failure, then you are realizing that PayPal provider is not behaving correctly. Now I want to move it into open state. So that's a careful thought. And yes, once you are in open for this much of time, even though PayPal is up and running, you will not talk to it because you want to give time to PayPal to stabilize. PayPal provider should stabilize, get back in a normal health, and then you will start calling them again full-fledged. So please be aware. You cannot keep open state for long time because all the request which comes in the system, if circuit breaker is in open, every request will be like failed, regardless of PayPal provider is up or running also. You will still assume it as failed. In interview time, they might put this scenario and like know your thought process. What do you think about this? And if you say, "Ke, "Arey yaar, ye to gadbad ho gayi." No, not gadbad ho gayi. You need to be careful how much time you should wait in open. So you have to keep it minimum. That is where 60 seconds ka waiting we have put in. If you want to make it more than 60 seconds, discuss it with the team. Sometimes practically you can wait for a few minutes also, but for that be very careful when you are moving in open state. So guys, these parameters needs to be dealt with very seriously. The values are very effective. Should 40% be considered as failure, or 60% be considered, or 20 should be considered? Everything is meaning. For how long you want to wait, everything has a meaning. Okay? So guys, let's draw this conclusion because it is an interesting thing to care about. Okay? What is the conclusion? When circuit breaker is in open state, okay, when circuit breaker is in open state, we don't call destination service, rather assume it is failure and handle at our end as a failure request. Okay, next observation. When you are in open state, you are tracking, okay, when you are in open state, the destination service might come up and start processing successfully. Okay, still source service is using failed fallback handling till the time it's waiting in open state. Okay, means even though destination is up and running, source considers it as failed. Okay, so be aware. Don't keep long waiting time in open state. Something like 60 seconds is good. Don't make it like 10 minutes, because 10 minutes all the requests will guaranteed failed if you reach into an open state, and that's a blunder, right? 10 minutes tak nothing is working, and it's like system is up but you are making a decision ke nahi karna hai. So be careful. 60 seconds is good. More than that, discuss it with the team. Okay, more than this, discuss with the team. And also, when to move from closed to open, those error threshold, okay, you need to be careful with this also. Decide this also very properly. Careful with these numbers as well. Not like 1-2 requests are failing and you assume ke nahi gaya service and move it into open. Don't do that. Okay, give it time. Sometimes few of the requests might fail, but the system is still healthy. It might still serve you. So be careful with it. Don't make it very narrow. Okay, 20% failure means gone service. No, don't do that. Okay, keep it bigger. 40%, sometimes 50, sometimes 60. It might be too much. 60% of your request is failing. That is concerning, right? So, but don't make it too narrow. 20%, 10%, very risky. 40 still looks like reasonable number. 50 also you can assume. Okay, you are giving 50-50 chance. That is still fine, but be careful. Okay, fine. So this is what is circuit breaker closed and open behavior. Guys, is this point clear, everyone? Is this point clear? Destination service might be up. Source is still assuming a failure because of open nature, open state. Okay, this point is clear, everybody, right? Okay, so please be aware there is risk with this, but we need to be aware of that and continue. You made a decision to go in open, so you need to already know ki this kind of risk is there. Otherwise, delay this decision. As simple as that. Okay, fine. Now let's put it into diagram and continue with half open state behavior. Good stuff, everybody. Let's continue to half open state. This is the final tweak and then we are done with this. Okay. Today experiment all this, the way we are getting into debugging, breaking point and understanding all flow, go to that level, you will get good control on this concept, plus API call clarity will happen, success, failure, both things. Acha practice hai. Okay, continue. We are here in the diagram. From closed, we moved into open. Open says you don't call destination service, rather call fallback and increment not permitted calls. Okay, next. This open state is automatically now moving into half open state. So if we go back here, and we already saw that why it is happening as well. Open state after some time moves into half open state. So that is the next status which comes in picture. Half open state. Okay. When does it come into half open state? Those two parameters are there. We can just copy it. We already discussed them as well. Wait duration in open state is set up to some value. So from open, it moves here. How? These parameters. So after whatever time you configure, let's take some example, okay, 60 seconds. After 60 seconds of time and informing automatic transition. This one. Automatic transition from open to half open. Okay. Based upon these two things, it is going to change the status. Okay. So let's try to put this back here. Drag it a bit. Fine. So just if you give it time, 60 seconds, based upon this configuration, you give it that time, and then it is, because it is automatic movement enabled, it will move here into half open. Okay, now what is this half open? And why half open? Why not full open? Okay, and full open mein gaya to everything is a failure anyway. So what is this half open state? Okay. So dekho guys, point is you need to keep checking in between whether destination service is up or not, right? Same previous problem. PayPal provider went down. If you now assume it to be open, means you are assuming every call is going to fail itself, because everything will be handled by fallback. So time to time, you want to check with PayPal. You want to check with the destination service, PayPal provider. Okay, is this guy up? Is this guy up? Is this guy up? That means some requests you will make directly to PayPal provider to see whether it is up and running. If it is up and running, then you assume, okay, hey, the full system is good. So the flow is going to be something like this. Half open state is for partial testing. What does this mean? Half open state means you will still see whether destination is up or not. You will make API calls to actual destination to see whether the destination is up or not. In open state, directly fallback was happening. In half open state, you will actually make the API call to the to the destination service to see whether it is up and running. But guys, you have to define how many calls you want to do. Again, same logic comes here as well. You can just define permitted number of calls in half open state. Guys, try to imagine, it's an automatic situation. You go into open state, you don't make any destination calls, right? When you go into open state, you don't make any destination calls. Everything comes from fallback. You wait there for 60 seconds. After 60 seconds, you move into half open. In half open, you will call destination service to see whether it is actually up or not. Okay, and this parameter defines permitted number of calls in half open state. Means in half open state, you will call only 2 times. And in the 2 times, you will interpret whether the destination service came up or not. If after 2 times, your conclusion is the destination service is up, you will move this half open state into closed state where everything works the way it was earlier working. So half open means intermediate state. to make a decision what to do for this system. Okay, so half open state can go in two directions. In half open state, now we are going to try 2 times. Okay, when you are in half open state, you are saying permitted number of calls in half open state is 2, means 2 times you will call and you will be actually calling the destination service. So in the half open state, 2 times you will call destination service to check if it's up and running. That is what is going to happen here. Okay, after making that decision, again it uses the same previous parameter, this error threshold based upon error rate. It will again be the same thing. 2 requests you call. If 1 request is success, 1 is failure, means 50% is still failure. Is 50 more than failure rate? Again, it compares that success failure again with the failure threshold itself. But for now, let's not again try to complicate. Keep things simple. When you are in half open state, you need to define how many calls you want to do. So we are saying do 2 times. So means 2 calls we will call to the third party destination service. From the 2 call, we will interpret whether the third destination service is up or not. If the conclusion comes the destination service is up and serving the request properly, then we will be moving it from half open state to open closed state, and all the previous logic will take into effect. Everything, whatever we were doing at close, that behavior will again be triggered back. So how this happens is, if you tried 2 times here in half open state, you tried to call 2 times. In 2 times, you interpret whether the destination is up or not. If your conclusion is yes, destination is up, you move the circuit breaker status into closed, where for every request it makes call to the third party only, to the destination service only. But after making these 2 calls, if you realize, okay, no, the destination is still not good, what do? You again move it back into open state. Because if it is still not up, then why do you even make it testing calls again and again? You again move it back from half open state into open state. So this is how the flow is going to go, guys. So closed becomes open, open becomes half open, and then half open decides whether destination service is up or not. If it is up, then moves it into closed, where the system works like every API call should go to destination. But if the conclusion is in half open is no, the destination is still not functioning properly, then it will move back into open state. And open state means you just do fallback dummy failure response processing. You don't call this, and it will keep going into this circle itself till the time end service stabilizes. It will not go into closed, where every call you are bombarding. And I think in the beginning of the session, that's what we said. What is circuit breaker? Whenever you realize the end system is not up, you stop calling them. You do a failure handling. But comes a question, for how long we should do failure handling? Half open is solving that. After every some time, you check, call the third party destination service and check whether it is up or not. If it is up, okay, all the future requests you go through them. If it is still not up, again work dummy. That is how, using these 3 statuses, circuit breaker achieves this decision making of when to go dummy, when to make API call, and gives time to the destination service to actually recover. Okay? So you need to be really very careful. Let's do the testing of half open state, and then that will be end of this full concept. Okay? Current situation is our system is already in half open state. So let's go back here and let's do some testing. Refresh. Okay, currently our system is already in half open state. Guys, it stays in half open state till the time you will do this. So there is no restriction. Wait, open state may after 3 minutes it moved, but it stays in half open state till the time you do this. It will wait. Even if you take your entire day, no API call happened, it will be happy in half open state. It will not change automatically. Okay? So currently we are saying our current configuration tells permitted number of calls in half open state is 2. Means in half open state, we will make 2 calls. These 2 calls should actually go to the PayPal provider service, destination, not just fallback. Based upon that, whatever is happening, accordingly, make a decision what to do, what not to do. Okay, chalo, we will keep the destination service still down. So currently what we will test here is, we will test the scenario like this, guys. We will keep PayPal provider still down. We are in half open state. We will keep the PayPal provider still down. And 2 API calls we will make. Both of them will be failed. And we will see, are we moving back into open state? So first we will test this flow. After that, we will wait for whatever 3 minutes, because till in open again the same current situation will happen where fallback method directly goes no calls. We will wait then for 3 minutes. After that, we will come back to half open again. Then we will start the PayPal provider service, and then we will make 2 API calls, and then let's see whether half open is becoming closed. And in closed, everything goes directly via the destination system till the time this logic hits and this loop keeps circling. So guys, what is our test scenario now? So you need to think how you can test with right logical approach, right? So our test scenario right now is, we are in half open state. Okay. 2 API calls. Keep PayPal provider testing in half open state. Okay. Keep PayPal provider down. Make 2 API calls. Both calls fail. Expectation is we should go back to open state. Okay, where the behavior will be like this. First, this is what we are going to focus and test upon. Chalo, so destination is down. We will make sure the breakpoints are not skipped. We want to test how it behaves in half open state, and let's test it out. Okay, so here we are. We are currently in half open state. Now we are making the first API call. Refresh this once more. Half open, making the first API call. Here we go. Go. Okay. Get order is being invoked. About to make HTTP call. About to make HTTP call. You call this. Observe. We are inside make HTTP call method. Nothing but trying to call the destination service. That is what our understanding was. In half open state, we call destination service to check if it is up and running. So this is the check number 1. We are actually trying to call destination, and let's see what happens. Okay, then we resume this. Currently the destination is again down, so the remaining behavior continues further. The destination is down. Circuit breaker sees, okay, half open, maybe try to see whether it is up or not. Circuit breaker realizes, oh, again it is a failure itself. Let me call the fallback handling, and then further whatever code you have written, you're throwing exception, it gives it, it goes here. First request failed. Let's go to the monitoring board, and here we are. Help. Again the same problem. We tried one and one is failed. We tried one and one is failed. Okay, no problem. We are still in half open. One more chance we are getting. Let's again try to produce the same case again. We go here, trying for another time. Second attempt. Okay, request came here. Go. About to make HTTP call. Go. Second time also, we are calling the PayPal provider because we really want it to be up and running. अभी चल नहीं रहा है तो what we can do, but we want it to work because then the system is stable. This is what microservice में you need to do failure handling based coding, right? Assuming a system might fluctuate, still how do you develop a stable system? That is where circuit breaker logic comes in picture. Okay, so for the second time we are again trying to check with PayPal provider, but currently that guy is again down itself, so it again throws back exception. Two times we tried, both of them are failing. Our handling is throwing exception. Circuit breaker says, oh, when you guys are throwing exception means the destination is still not working. If it is not working, PayPal provider says, okay, circuit breaker says fallback handling, let's execute, increments the failure count, and now two times were permitted calls. Let's see what it does. Circuit breaker logic. It goes here, and now we are about to refresh. Just see, it moved it back into open state. Two times we said we will try only two times. From there we will try to define whether destination is up or not. We tried two times. Both the times failed. Nothing but 100% failure happened. If 100% failure is happening, it is more than the threshold which you have set up, 40%. Circuit breaker makes a decision, means destination is not up. Let me move it back into open state only. So this flow happened. We practically saw made two calls, both of them failed. We practically saw that this movement happened. Now we are in open state. Abhi open state mein baithe hai. For 3 minutes we are sitting here because in our property file it is set to 180. It will stay here for 180 seconds. After that, it will again move back into half open. Till this 180 seconds happen, every request will be not going to destination. All requests will go to fallback handling directly. That is the nature of open state. We can test it once since we are waiting here anyways for 3 minutes. So we call this. You go here, get call, about to call make HTTP, but bypassed. So when you're in open state, it bypasses. Okay, like, okay, system is down. What are you doing actually calling it? Why adding to the network layer? Don't go there. Simply assume it a failure, process it accordingly. You're giving time to the PayPal provider to recover, hoping that it will come back again. Okay? So now you are in exception, and now, yes, this is gone. And here you can see, okay, we are still waiting. In open state, not permitted call has become 1. In open state, not permitted call has become 1. Okay? Now for 3 minutes, idhar hi gaadi chalegi. Okay? So we can still just maybe skip all breakpoints and keep doing some testing till the time it becomes half open. Okay, let's call it 2, 3. Let's go here. Just see, not permitted calls are 4. Okay, so chalo, let's wait that it becomes half open again. Meanwhile, we will just put these learnings into notepad notes. Okay, chalo. So when does it move here? 2 times you will call destination to check whether it is up and running. Okay, next, for this decision also you will use the same logic. So we will copy this, copy paste, and we will put it here. Not like this. Let's copy this. Okay, still. Okay. Here also same logic is going to be determined. Just that via 2 requests, because permitted number of call is 2. Okay. So this is what it is. Let's take some notes about it. When you are in half open, you call destination service based on this parameter. Based on this parameter. Okay. From these two attempts, okay, determine whether destination service is up or down. Okay. After end of two attempts, check the failure rate, compare with the threshold, and decide if destination is up or not. Right? So if you are more than threshold, right? If you are more than threshold, for example, more than 40% failure rate, okay, then move to open state. And in open state, all requests will be considered as failed, and you would reply with dummy fallback handling. Okay. After waiting in open state, it will move back to half open to check again if destination service came up for processing. Okay. And now the further flow continues. Again, it tries 2 times. If this time failure rate is less than threshold, then status move to closed status. In closed, all requests will go to destination and entire process continues all over again. Okay? So this is how we are about to just test the final this piece now. Okay? Chalo, let's test it out. So here we are. Hopefully 3 minutes have passed by the time we are doing all that. Yes, it is passed. So the numbers are reset. Status is here. Okay, it's ready to do processing again. So we go back here, and first we need to bring the service up. So we go to PayPal provider. PayPal provider. Right click. Run as Spring Boot app. Go. Okay. So PayPal provider. Service is up and running. Now we are in half open state already. So we can do some testing as well. And it will call the destination itself. Let's do the testing. Circuit breaker skip points. Let's remove it. And let's try to test it once. Both services are up. We go here. Shoot. We are back here. Get order from PayPal provider. Okay. About to make HTTP call. We are in half open state. So we make that call. We are making the destination call. And now we are calling the destination. Destination responded back with success. Chal gaya. Because PayPal provider service is up. Destination came back with success. It's not a failure anymore. Wonderful. You reply back. No exception. So no fallback handling, nothing. Circuit breaker is like, "Arey wah, chal gaya hai beta. Very good." The circuit breaker is now happy. Okay, so this time it is success, means service is coming up. Awesome. And then it continues. Okay, circuit breaker internally changes the stats accordingly. One request you called, there is 0 failed in that. Awesome. Circuit breaker says, okay, 2 times karna hai, lekin not just one. One is not enough for conclusion. You are saying, your configuration is saying 2 times you should try. Okay, second attempt also, circuit breaker says, let them make 2. Then I will define what is success and then I will decide what to do. Okay, so now we are making second API call again. One more request is coming. Go. It comes here. Get call, get order. Okay. Next, make HTTP call. About to call, make HTTP call. Getting inside, make HTTP call. So second request is actually going to the destination to see whether it is behaving properly or not. Okay. Next, it is behaving. It responded back properly. There was no timeout this time again. So no fallback and all that drama. Everything came back to success. The regular code is working. And then you release it. You go back here and you do refresh. Just observe. It bridged the flow into closed. It bridged the flow into closed. So 2 times, observe another thing. 2 times it did, and both of them it realized, okay, full movement has happened, moved it, and everything is reset. Means it's a new journey altogether now. So that means your full circle came back. It calculated internally the failure rate threshold, and then it checked it against these things, and it did all that, and finally realized both 100% is success, 0 failure has happened, and just moved it into closed, where now it is ready for all of this next drama. Okay, guys, clear with this? There are 2 more configurations we need to understand. Are we clear with this? We are done. This is the major flow. Simple. Internally, it uses all these parameters. It reads our configuration and just impacts. Kya karna hai as a developer? Form, property file, one annotation, one method, but so much big capability we are getting, right? That is so amazing. Okay? Life of developer is simplified by framework. Further, AI is coming and even more simplifying. So developer is now very much in a chill state. Complexity is just dealt with annotations, right? Such a simple system. Okay, let's just focus on this last 2 configuration, and then we will take the attendance and close the session. Okay, matter of 5 minutes here, guys. All the configurations we understood. There is these 2 last configurations. Just put a focus. Processing service here. These 2 things. Remaining everything is okay. Observe these 2 things. Sliding window size and count based. Nothing but this is the approach. We are saying, right, failures should be tracked and then compared for failure rate and then measured. How it did that is based upon these 2 mechanisms. Sliding window. Okay? Nothing but consider last 10 attempts and then do the processing. For example, just see, observe here, guys. Just theoretically we will do. It can be practically demonstrated again, but it will need again more time to arrange and test it. So I'll explain you the concept here about how this sliding window is going to work here. Sliding window size. Just think about it from this perspective. We are in closed state currently. Currently, we are in closed state. All the numbers are 0. Now, let's say everything is, whatever, system is up, you are doing this, that, blah, blah, blah. Minimum 5, you will start calculating. That is okay. So we already know that, okay, when we are in closed state, minimum number of calls are 5. But now let's assume those 5 calls are successful. Okay. After that, then 6th call is happening and 6th is failing. So sliding window says he consider the last 10 attempts, and in the last 10 attempts, then you try to compare the failure rate. That is what this sliding window means. Consider last 10 attempts. So it could be possible initially 5 were success, but after that you got failure. So accordingly keep doing it. We can actually demonstrate it as well, guys. Okay, let's try to focus here. Sliding window concept, small demonstration. If we try to test it, now we are in closed state, means we are calling third party. Okay, I will just skip this breakpoints. I'm skipping, and let's just call this 1. PayPal provider is up and running. You go here. Request 1 not considered as a failure. Okay. Request number 2. Refresh. Request number 2 not considered as failure. Next, request number 3. Refresh. Request 3 not considered as failure. Request number 4. I'm trying to demonstrate that 10 window, sliding window of 10. Okay. So 4 we tried. Okay, again 4 are successful, no failed attempt. Minimum number to calculate failure rate is 5. Now let's do the 5th attempt. We come back here for the 5th attempt. Just observe. As soon as you did 5, earlier this was -1. Now it became 0. Why it is happening? Because of these parameters only. It came here, minimum number of calls 5. After 5 happened, it tried to read the last 10. But the point is, it started from 0. So only 5 were available. It considered only that much. But it is considering, let's say, if 100 API calls are made, it will not look average failure of 100 API calls. It will look only of the last 10 attempts. Please be aware of that. So it's just a sliding window. And that is what it is of the nature count based. Nothing but you are counting how many failures happened, how many success happened, every API. So your sliding window is a count based window, and you will consider only last 10. So for example, if currently I keep doing more 5 attempts and all of that becomes successful, so that means past 10 happened, and in that 0 failure rate, right? This is what it is. Now we can do one experiment. We tried 5 and all of them is success. Let's try one more. Let's make it a 6. Okay, 6. Go, refresh. Okay, 6. 0 failure so far. So it calculated how much failure? 0 failure. Let's introduce a failure now. We will go back here. Kill provider service, PayPal provider. Let's stop it. Gone. Processing service is up and running. Okay. Now we are trying to produce a failure here intentionally. Let's go back. Current situation is like this. 6 times we called. Refresh. Let's call it here. Go. Okay, this failed. Refresh. Just observe. Percentage calculation game has started. It starts now calculating. Out of total 7 requests, last 10 it considers. So currently we started from 0. So it is now seeing 7 has happened. So out of 7, 1 has failed. The failure percentage, if you calculate, it is going to be 14%. If this percentage is less than the threshold, Yeah, it is less than the threshold. So you continue to be in the closed state. I think this is where you will understand now this logic even more deeper. When number of calls is 5, then you calculate failure rate. And after this point, you keep calculating failure rate with every new success or failure that is happening. Next, if failure rate is greater than threshold, then you move here. If it is less, you stay here. For example, now we will do one more attempt of failure itself. Second request, again failing. You come back here, you refresh it. Just see 25% failure. From 8 calls, 2 calls failed, means 25% failure. Is 25 less than 40? Yes, it is less than 40. Okay, no problem. Stay in closed state. Make call to destination service every time because developer has configured it to be less than 40. It's okay. Next, call once more. Again, a failure we will try. Last 10 records will be considered. Okay, this again is a failure. We go here and then we try to refresh. Now just see that 25% now became 33. Nothing but from 9 requests, 3 requests are failed. Means total of 33% ho gaya. Guys, as soon as one more request failed, it will touch our threshold. And if it touches our threshold, basically the game is changed, right? Open becomes closed, becomes open because you have hit the threshold. So till the time you are not hitting the threshold, you every time we call destination. So please be aware, the sliding window concept is last 10 it considers. Let hit it one more time. We go here and now we shoot. As soon as you call, you come here, refresh, observe. Things are changed. 10 requests you made, 4 has failed. Failure rate is 40%. It is as per the threshold, hit the threshold. State is changed to open. Now every API call that you make will be processed by the dummy. That is sliding window. Consider sliding window. Abhi, whatever you call you make, everything will just go as not permitted. Doesn't matter whether PayPal provider is up or not, everything is not permitted. And guys, the same cycle keeps happening over and over till the entire lifetime of this circuit breaker. Okay, so keep checking how the third party, how the destination service is. If not behaving, go into open. From there, just do static failure responses. After some time, see whether it is up. If it is up, then go back to normal way, just calling them. If they are still not up, start using dummy. And this always runs on all of these microservices. Anyone who is calling the destination will have circuit breaker code implemented. Okay? That is what is the mechanism. Guys, everybody clear with this? Chalo, I think we are done with the final 2 configurations also. Guys, here? okays. Chalo, let's take the attendance. Practices today. Experiment. If you're getting further more thoughts, play around with ChatGPT. Check what more can be played around. And I think in interview time, definitely working with circuit breaker. Okay, for juniors, they might say, okay, explain circuit breaker. 10 minutes tak to ye conversation itself might happen. One entire project, one side, interviewer might be explain me circuit breaker. So every topic is huge capability, right? Recon, 30 minutes topic easily, right? PayPal integration, 30 minutes. Project interview is what? Project discussion is like 30 minutes ka discussion hota hai. You have so much knowledge. Practice and showcase. Okay? Good stuff, everyone. Okay? So all the best. Let's take the attendance and we will then continue tomorrow with service registry concept of microservices. Okay? Chalo guys, everybody. Let's take the attendance. Good stuff, everyone. Good stuff. We are into the final week. Next week, we don't have any live sessions. You will be fully focusing on completing your tasks, demos. More important, guys, focus on the demos part. Okay? Because completion letters will be issued based upon the demo criteria. So either 5 demo or 7 demo. So please stick with it. Okay? You can pick any topic if you are thinking, okay, you have done only week 1, week 2, week 3. From those 3 weeks itself, prepare 5 to 7 demos, because we have many topics. Just pick up any topic from our discussions that we did on a daily basis. Okay? Make sure theory plus practical is there, 30 minutes per demo, and every topic of demo should be independent. Okay? By that way, you will cover more concepts and learn better. Okay, 4444. That's the code for today. Please take the link. Okay, guys. So very interesting concept. So along with the remaining discussions of microservice, what we did, even technically include this into your resume and showcase during interview. Tomorrow we will speak about service registry and how to work with that. However, you can completely tell during interview, okay, we did not use service registry in our project. However, you have done a POC for that. Okay? And tomorrow we will discuss about it, okay, why that kind of decision is done. They might ask you, why did you decide like that? So there are reasons, pros and cons with both the approaches. When to go with direct endpoint, when to go with service registry. Tomorrow we will discuss that. So accordingly, based upon your preparation, you can say. Chalo. Okay, thanks everybody. Stopping the recordings and continue for the day. Today's practical will be doing all of these things. I'll share the recordings, this document and everything. Okay? So thank you everybody. Have a great day, guys. Have a great day, everyone. All 5 days important topic. So thank you all. Stopping the stream, stopping transcription. So take care. Thank you everybody. Bye-bye. Bye team.